All right, so let's get started. We're back on ignition systems, but it's part two, which is really more like diagnosis. And I'll add to that, it's service as well. So you should have a pretty good understanding of the system now. It's like we were talking about with that check engine light. If you understood the system and you understood how to service it, how to diagnose it, you'd be pretty well equipped to do the diagnosis. So if it's ignition system related, you should have the base overall understanding of the ignition system, what the components are, kind of how they function, a little bit about primary versus secondary, a bit about some of the types of tests we should do. But here we're going to talk about the actual tests, okay? So the very, very first thing we're going to talk about is the modern system that cars are using right now is coil on plug ignition. So this is a picture you've seen before, but we've got the coil on plug right there. So if we have a spark issue, we're not looking at a distributor and a pickup and spark plug wires. We're looking more at like an individual coil on the spark plug. So because this is the case, it really does change our diagnosis quite a bit. And because we have some different testing methods, the way I would diagnose a current ignition system is going to be a little bit different. However, we're going to go thoroughly through all the tests that you can do because you need to understand them, but I'll make the most practical, simple right up front. If we had a misfire on a vehicle like this, and let's say this is cylinder 1, this is cylinder 3, and this is cylinder 5. If you had a misfire on cylinder number 3, how could you tell if it was the coil? Tell me. And that's what I would do. And honestly, I think that's great diagnosis. It's not something you can be real proud about. Be like, I am ASE certified, and the way I diagnose the car is I swap one coil to the next. But the truth is, a lot of what drives the world is money, right? So if you tell the customer, hey, we need to spend a lot of time and we need to get an oscilloscope out here and we need to get our probes and an inductive probe and a this probe and a that probe and the other probe so that we can look at the waveform of the ignition coil so that we can tell you what's going on. It's going to be like, okay, how much does that cost? And you're like, $500. And they're like, well, I found somebody down the road that just said they could diagnose it for $100. They're probably going to go with the $100 diagnosis, right? So sometimes we just keep it simple, stupid. You've heard the method, right? The KISS method. That doesn't mean kiss everybody. It means keep it simple, stupid. Like you got 6 coils on this engine. If you think you got a bad coil on 3, swap it. In fact, I would take it a step further. Do you think it could be the spark plug too? Spark plug could cause a potential misfire, right? I would say if you really wanted to, you could take coil number 3, move it to 1, and take spark plug number 3, move it to 5, and then make a little note, write it down in your hand or whatever, or just remember it, but don't forget. And then, let's say it had the misfire on 3, then you're going to start it up and you're going to look at either the misfire counter. We talked about that in scan tool diagnose a little bit, or you could clear the code. And if you recall, when we talked about DTCs, a misfire in cylinder 3 is a P303. If you start it and it's still misfiring and now it's a P301, what do you think the failure is? Do you remember we moved the coil from 3 to 1? Exactly. But what if it was a P305? Exactly. And you're like, and that took you how long? Not much time. So that's legitimate diagnosis. It's not that cool. You don't have to be that smart. But if you keep it simple, stupid, that's what I would do. Cool. Now, and that's fairly easy, right? If the misfire follows the spark plug, it's the spark plug. Are we going to do one spark plug? Probably not. Probably going to do the set of 6 in this V6. If it was the coil and it follows the coil, what's the car need? A coil. And then you get into this whole debate of like, well, if you do one coil, the other coils are going to need to be done too. But, I'm all about this. I like to give the customer options and I just speak in facts and that's it. I don't say like, well, I know that your other coils are going to go bad because do you know that? I mean, that's the future. Like, we don't really know that. So I'd give them the fact of this, like, hey, The issue is the coil. I'm still going to charge diagnosis, by the way. And there's a few justifications for that. Like if you wanted me to clock out from work and do charity work, I'm good with that. That is something that, is nice, and I'd like to do that. But when someone comes to the shop, they're not, their priority is getting it fixed. They're not, if they're looking for charity work, they're probably not coming to the place of business, right? They're going to the church, and then the church is going to handle it, or they're going to hire somebody or whatever. But if they're at the shop, what we really need to do? We need to make sure it's the problem. The worst thing you could do is be like, well, I think it could be the coil, so let's replace all the coils. You just wasted a whole bunch of their money, right? So however we nail this down to diagnose it is exactly what you should do. And if it takes you less time because you understand the system, because you've studied, you've put in the work, if it takes you less time because you have the latest and greatest fancy tool or whatever, we got to have a way to pay for that, right? So you're all studying in class right now. It's kind of like a lawyer or a doctor. They go to school for a long time, right? That costs money, that costs time. They're not making money doing a job because they're going to school. Well, logically, the result's going to be they're going to get paid more when they finish school, right? So when you guys finish school and you understand this, you're worth more money per hour. I'm still charging the diagnosis. That's really my point. I'm not just going to say, well, switch it. Now, like I told you a week or so ago, the customer who called with the mobile mechanic story, if it's somebody like that, and I'm kind of like, you know what? If all I do is give you advice over the phone, I won't bill you. Just switch the coils and see if it follows. I'm good with giving that advice. But if I'm going to physically do it, that's part of my diagnosis. Great. So if I tell the customer, as a matter of fact, it's the coil because the misfire followed, I would give them the option of, I know it's the coil. I can guarantee it's the coil. However, if we replace your coil for cylinder number 3, I'm good with that. This is the price. But if you have another coil that fails, it's going to feel the same. It's going to run the same. You're going to get the same check engine light. So I want to let you know that you had one coil fail, and another coil may or may not fail soon. I don't know. Probably it'll eventually fail. If it fails next week, though, and you come back, I don't want you to think I'm scamming you. So I just want to let you know, one coil's bad. You do one coil, you might have another coil fail any day. You do all the coils, then what? Probably not going to have any more coil failures. So is it a better repair to do all 6 in this case? Yeah, maybe. But how much are they? That's kind of another thing, right? So if you want to make it a better repair by going on Amazon and buying the Chinese coils that are $200 for all 6 of them, I don't know. Personally, I probably would have done one good brand replacement and not done the other 5, right? So if you look, let's say these coils are made by Denso, I would replace a Denso coil with a Denso coil. The Denso coil lasts however many years the car is. The car didn't come with made in China Amazon coils. They didn't come with the flea bay coils. They didn't. And there's a reason that the original manufacturer is not using the cheapest of the cheapest coils, because they're probably not going to last as long. They're not as well tested. Maybe you get lucky though. I have heard some people say, yeah, I put all these Amazon coils in and it was good to go. But like typically as a professional in a shop, we got to warranty that vehicle with that repair for 1 year, 12,000 miles is pretty normal. Sometimes the shop will do a two-year, 24,000. If the coil from Amazon doesn't last, the customer is going to get a free coil, right? And they're going to get free labor. And now you're doing free labor. So I'm all about options, but I just want to give them the facts. You can do the cheap coils and it might be great. You could do the cheap coils and they might come back immediately, but I'm not going to take responsibility for if those cheap coils fail. Or I'm not going to take responsibility for if you only do one coil and the coil next to fail. We'll just charge you again. I'll charge you the diagnosis again. So one way to maybe word it to a customer who does have, a good budget is, you paid me the diagnosis to diagnose coil number 3. If we replace coil number 3 and then you get another misfire, I got to do the diagnosis again to determine which cylinder it is. You're going to pay the diagnosis again, and I'm going to replace one more coil. And then a year later, you're going to pay me the diagnosis again to diagnose which coil it is. you see how that's more expensive? So if they've got the budget and you're like, hey, let's just do 6 brand new Denso high quality coils, it might actually save the customer money over time, but you don't know the customer's details, right? You don't know if they're struggling to pay their bills at the end of the month. If they're struggling to pay their bills at the end of the month, I don't think I'd throw 6 coils at it. I think I'd probably do 1 and see how long it lasts. Make sense? So this is where we do a lot of our diagnosis. But aside from swapping the coils, and that's like, that's quick, it's good. There's a few more things we could do. So if you look at this, one way to know without doing the swap and the retest drive and whatever, one way to know if this coil's working is we could see if it's outputting a sparks. Anybody know how we would do that? There's a couple options. You familiar with this one?
Take out the coil, just the coil, and you start it and see if it sparks.
Okay. I like that answer. That's exactly the answer I wanted. Technically, that will work. But a little bit later in the presentation, that's why I could give you the down and dirty and be done in 30 minutes and be like, yeah, that's how you do it. But I want to explain why I probably wouldn't totally recommend that one, even though if I'm in a jam, I'm going to do it, but I'm going to do it for a very short period of time. I'll explain extensively why. So yes, you could unbolt the 10 millimeter in this coil. You could slide it out. You have to keep the primary wires plugged in, and then you can crank it, and this sucker will spark to whatever ground is nearby, right? As long as it's near a ground, you'll see a little arc, a little lightning from the coil to the valve cover, to the bolt, or to the whatever, to something, and be like, oh yeah, that coil's firing. Do you think that measures the voltage accurately though? Or like measures, yeah, so like it's a good way to know if the coil's firing at all or not, but it doesn't give you a really thorough and complete picture. There's 2 more problems with that. One, I don't want you to ask me a lot of questions about this. I'm just going to tell you what could happen, and you probably have an idea of how I know this. If the vehicle has, let's say, a fuel leak, or if you just did some work and there's gas fumes around here, and it sparks right here, what you think's gonna happen? Poof! It's on fire. At that point, you got a few options. You get the hose, and actually the hose will probably put that out pretty well. But where's the hose at? If the hose is over there and it's tangled up and whatever, the car's on fire, like get the hose. Or the fire extinguisher. You could do that, but that makes a mess. If it's burn down the shop or get the fire extinguisher, make a mess, make the mess. But like, don't think that using a fire extinguisher is like a little thing. That thing's hammered. They also make a fire blanket, which would be a pretty cool thing. But again, just don't catch the thing on fire. That'd probably start with that. Don't catch on fire. That test right there can absolutely have an open spark. And if there's fuel vapor around, that will start a fire, FYI. Okay. Another thing we could do is actually where we're going to go right now is I like to do it just live with you so you guys can see. Let's just say that you wanted a tool to be able to do that. We could look up a spark tester, and you have to actually type. What? Why would I have to not be a robot to search for a spark tester? Oh. Oh my goodness, you got to be kidding me. Wow. Okay, so we got a few options. Let's start with this one. This one's a really good example. Straight from Hobo Freight. Here we've got a nice inline spark tester. You like that, huh? This is a cool one. I'll tell you there's some negatives about this though. If you look right here, your coil's going to clip on this end, and then this end is going to clip on your spark plug. So it's what we call an inline. It's an inline spark tester. There is no spark actually. All it does is light a little light bulb in here, and that will tell you if it's making a spark. It'll more tell you like, is it outputting secondary ignition voltage? All right. So the positive is this going to start a fire? No, it's all enclosed. There's not even really an arc. There's really just a light bulb lighting. You're like, oh yeah, that's pulsing. And I actually have this one. And I believe I paid the same price 20 years ago from the same place. $5 whole. Some things, but not all things. Yeah. So this would be a good basic one. I'll tell you the negative though. This is not really measuring the amount of voltage. It's more like you might have a coil that puts out a spark, but the voltage may not be high enough to really jump the gap on the spark plug. This is not helpful in that way. The other thing is we're looking at coil on plug. This is, you're not going to get that way down in the cylinder, you know, so this is a good tester for a lawnmower or an old car, maybe, but maybe even a moped or any sort of other, like a small engine thing that doesn't, you know, that doesn't have to put out a really high amount of voltage to arc the gap, to jump the gap on the spark plug, right? But it's a basic one. It's a good one. I'll still use it, but if you really want to test the quality of the spark, or you know, the voltage level of the coil, which determines how far the gap, how far the arc can travel. This is actually another really good one right here. This is from OTC. OTC is a professional brand. They make a lot of tools for the original equipment manufacturer. If you look at, wait, does that look like a spark plug?
Yeah.
Sunny Beach. You could potentially use the spark plug. Didn't mention that. But you'd have to take the spark plug out of the cylinder, or you'd have to have a spark plug you keep around, and you could basically plug the spark plug into the coil or the wire later, right? If it's a system with wires with a distributor, and you can literally lay the spark plug on a ground, and you can watch the arc go from the center electrode to the side electrode where the little strap is on the spark plug. You can use the spark plug. You understand? So if you can use the spark plug, why would you get this tool? Kind of, but this measures it the same way as a spark plug does. You don't measure voltage and get a number, but if it can arc this gap right here, it can jump the spark plug gap too, right? So you're just visualizing it. You know why this one is $30? Because it has this little clamp right here. So, you know, for some reason, spot, you know what you do? You go to grab it to fix it while someone's cranking it, and you get your, that's how I lost my hair. Zomp! It's got spark. How do I know? Because it knocked me off my feet and I lost my hair. You know, that type of thing. So this is a good tool. But we're back to the issue of if there's fuel vapor around, this can start a fire too. All right, so you just got to be aware. We'll probably be using this in another couple hours. Good tool, not that expensive either. Or let's see what else we can get here. Ooh, an inline spark checker for 107. I'm fairly certain I know which one this is. Oh, this one has Noid lights too. This is a cool one, but this has the adapter for the coil on plug, so that part's nice, but this is actually not the type. Adjustable. All right, something like this is going to be really cool. Let's see if this. See this end right here? That's where we're going to connect the coil or the wire. And then you see this end down here? That's where we're going to connect it to ground. You can see that, right? So where does the spark occur? See that tube right there? That's glass. So if you look at that glass tube, let's see if like maybe this one. The arc is going to start up here and it's going to make it all the way down to here. How would you measure the strength of the spark? Bingo. So that's actually a pretty effective way to measure it. So if you want to know the voltage, we're typically going to call that kilovolts because it's thousands of volts. We're not talking about 12 or 13 volts. We're talking about 20 or 40 or 60,000. So rather than say 1,000, let's just say kilovolts, which is a little silly, but if it's 20 kV, you know, that may be one of these markers up here. If it's 40 kV, you may adjust it to this gap. If the service information says the secondary ignition voltage should be 60 kV, maybe that's this line way down here, right? So you can see this part's threaded and you can adjust the distance. And so if it's calling for a minimum 60 kV and you adjust the distance to what 60 kV is, and it jumps the gap, that tells you that it's putting out enough secondary voltage to jump the gap. There's a couple of points that are made a little bit later, but I'd like to point them out. Your spark plug gap is never going to be this big. So why would we test it that big? Well, I'll tell you. When the spark plug is in the cylinder and there's air-fuel ratio, depending on what the air-fuel ratio is, and also there's cylinder pressure, right? Because you know how it's under compression? It actually makes it harder to jump the gap, right? So we may need 60 kV, which can jump this huge gap, but it only needs to jump a small gap on the spark plug. But the thing is, when your spark plug's in the cylinder with that pressure and all that type of stuff, it's almost like it's a bigger gap. So we need to make sure it can really jump the gap. When you start to get a coil that's got a little bit low secondary voltage, it might jump the gap at idle. It might jump the gap if you pull the spark plug out and you look at the spark plug and you're like, oh yeah, it's sparking. And then you grab it and you're like, oh yeah, it's definitely sparking. But the thing is, in the cylinder, it's a different testing environment. In the cylinder, it's a much harder environment. It has to jump the same gap under pressure, which is almost like double or triple the gap. Make sense? So this tester is really good because you can actually measure, is the coil up to the job under pressure? Cool, makes sense? So that one's good. And you can see that one's pretty inexpensive too. This would actually be a better tool than that inline one. Yeah, and it looks like it'll work pretty well with a coil plug because you could pull the coil on plug out, put it there, and then you could just ground this to like the valve cover bolt. That'd be a pretty good tool. And it's only 15 bucks. How long it'll last, I don't know. But the actual layout of the tool is pretty good. A lot of companies make that tool though. That tool's sold by a bunch of people. All right, so if we're back to here and you say, I think it's got a bad coil, you got option A, do the switch and see if it follows. And like I said, that is a good option. Or you got option B, pull the spark plug out and do a spark test, which you need a little bit more tools for, but you saw the tools are pretty inexpensive. So you don't really have a good reason to be like, I can't afford that. It's not that much money. All right. So, and plus, remember, we charge a diagnosis fee. Like, we're not trying to hurt ourselves and be like, well, I'll do free diagnosis, but in the meantime, you can't even afford the tools to do the diagnosis. Can you think of a doctor's office working that way? Being like, well, we want to keep our prices low so we don't have a stethoscope, but let me just put my ear up against your chest and be like, whoa, dude, like, you can raise your prices if it means you don't have to get all up in my personal space. You know, like if you need a stethoscope, get a stethoscope. You can raise the cost of my physical by $1 or whatever, right? So the tools we need tend to set the price of the work that we do. It's just, it kind of makes sense. All right, so now if you look at this again, we got 6 spark plugs. This part down here is secondary ignition voltage. But what about the small wires that go in there? What would you call those? Kind of gave it away. The primary, exactly. So on a coil on plug, if you need to test the primary voltage, it's not a really big deal. We'll test that with our meter, right? So there's some basic diagnosis we could do. Sometimes I'll shortcut that. And, you know, let's just say we move the spark plug from 3 to 1, and we move the coil from 3 to 1 and move the spark plug from 3 to 5, but then we start it up and it still misfires on cylinder number 3. Does it need a new coil or a new spark plug? Neither. It really needs to be figured out. That's right. And so typically that's where the DIY people run out of gas. And they're like, well, remember I told you about that one last week? She called and said I had a misfire and it didn't follow the coil. And so she determined it must be the spark plug, right? Well, the thing is, there's other stuff that could cause it, right? If you don't have the right primary ignition voltage, you are not going to have the right secondary ignition voltage. Primary makes the secondary. So if the primary is no good, the secondary is definitely no good. Yeah, she didn't say. So the little summary was the misfire was here. The coil went here, it didn't fire. So she determined it would have to be the spark plug. I said, well, it could be, but there's other things it could be. And then she determined to say there's a check engine light, and the DTC was for primary ignition circuit voltage. So at that point, because I understand the system, which is where I want you to be, I'd be like, hold up, you're going after the spark plug? Well, first off, remember I said, if you're stuck on getting the spark plug out because your ratchet's not long enough, like you really have no business trying to pursue the diagnosis of diagnosis takes a lot more understanding than getting a spark plug out. So like pause right there. Let's readdress. When I knew it had a primary ignition voltage code, the primary issue, that's all on the small 12-volt little wires, right? So I said, forget the spark plug. The spark plug could cause a misfire, yes, but the spark plug will never cause a primary ignition voltage code. So just leave the spark plug alone, stop wasting time trying to get the spark plug out and get a longer ratchet and just be done with that. My suspicion is you have an open circuit on the primary wires between the coil and the ECM. So start looking those over. And then if you'll recall, I got a picture of a wire chewed right at the coil. And it's like, they're going to do this. So if you got a misfire, we're going to pop the hood, and we might check codes first, or sometimes I'll visually inspect it, right? But just understand, if the small wires go into the coils on coil unplug get chewed, that coil will not fire. Make sense? So in her case, when she showed the damage of the wire at the connector, it was like, hey, you got to buy a new connector with the little pigtail harness, crimp those on, plug it in. I haven't got a call. It's been 2 weeks. She probably took care of it. And that was just a couple minutes on the phone, turned in a little while because there was an argument. I mean, it wasn't like a nasty argument, but it was like, well, my other mechanic said it could be the spark plug. It's like, look, we're not going to keep going over this. Like I'm just going to give you the facts, and you can say you don't like my answer, and you can say you feel it's a different answer, and you don't want it to be that, and that's fine. I don't get involved in that. But the matter of the fact is, primary ignition code, we're talking small wires right here. Primary ignition code will cause a misfire. It's just the way it is. So let's just say you wanted to diagnose the primary ignition side. That's when we need to get into like that ASE within electrical module we did before, that unit. It's going to be, well, what's it need? It's probably going to be like 12 volts. And then maybe the ground is going to be controlled by the ECM. It's going to be pulsed or whatever. So some of this we'll get into a little bit more, but as an overall, if the problem's in the coil, we spark check, we switch, whatever. But if it doesn't move, then we're like, all right, cool. That misfire could be down. It could be a fuel problem, injector issue. It could be low compression issue, right? Which is why I would go to the spark tester. If you pull the coil out, you hook up the spark tester, and that coil doesn't spark, boom. We know for sure that we're dealing with a no spark issue. But why? It's not the coil because it didn't follow. It could be it's going to have to be an issue on the primary ignition. At that point, we're looking at the diagram. We're seeing what voltage it should have, what signal it should be getting from the ECM, right? And then we're like, hey, it doesn't have voltage. And then we would just trace the wiring diagram down and find out why it doesn't have voltage. Maybe it got chewed. Maybe the ECM transistor is not giving the signal for the ground, right? So we'll come up to that a little bit towards the end. Because we do talk about testing the primary side, but this is what you're mostly working on. Go ahead.
The car has like over 200,000 miles.
Uh-huh.
Be like just the engine and stuff.
For sure. I mean, but I've seen vehicles with 12,000 miles have low compression. So, there's a reason that cars come with a warranty. Manufacturer defects are a thing. So like, I'll give you a good example and make sure you understand. I don't know what year it was before I started, but when I went to the shop, I kind of had that type of mentality. Like, it's low miles. It's not going to be the engine. It's probably going to be the spark plug or the coil. And then they'd be like, well, we can't say probably. We've got to prove our theory, right? So it's kind of like, yeah, but I mean, the engine's new. Like, what's going to go wrong? And they said, we've got engines brand new, 0 miles on them with misfires, and had it be the engine. And I'm like, how? That's impossible. And they said, no, back in the day, GM employees were upset with their pay, so I'm not recommending this. I'm just saying this did happen as a matter of fact. So they said, hey, we want more money or whatever. And GM's like, nope, we're going to pay you whatever they pay you. I don't know. Some of those auto workers get paid kind of a lot of money per hour. And so rather than go on strike, like it was before they were going to go on strike, they started taking their revenge. Yeah. So they would pick a cylinder, let's say in this case, cylinder 3, and they'd line up all the piston rings. Your piston rings come around, there's an end gap right here. And that little gap, compression leaks out. So you put one here, and you put one here, and then they're always going to be offset. Well, if you line them right up straight, it'll lose compression. So these cars with 0 miles would come off the car and they'd be misfiring, and they'd be like, oh, well, maybe it's the cap and the rotor and the spark plugs and the wires and the whatever. And then they do a compression test. It's got low compression. And they're like, what the heck is this? Pull it apart, find all the piston rings lined up, re-index the piston rings, put it back together and fixes it, right? So you can't assume that it's not an engine issue, even with 0 miles, let alone with 10,000, 100,000, 200,000. Anything's possible, right? So we did the compression and the base engine stuff. If you got a misfire, I'd probably actually start with a spark test because it's easier and faster. But if you pull the spark plug, the coil out, right, you hook your spark tester on there and it's got spark, then cool, let's go right for compression because your coil's already out. And if you got compression, then you're kind of stuck with fuel. And you're like, well, fuel's a little tougher to test, but we'll get to that one next unit. But for now, let's focus on it's just a no spark. Cool. How do you know it's a no spark? You pulled the coil out, you tested the spark, it doesn't spark. It could be the coil, a problem with the coil itself. Or it could be the primary. And so the way we test the primary, we're definitely going to spend a little time on that because that's something you're going to have to do. It's not always going to be the coil, and it's not always going to be the spark plug. Makes sense? It could absolutely be the primary side, like the example with the chewed harness. Cool. All right, now we'll back up just a little bit too. How do these coils know when to fire? ECU makes them fire, but how does the ECU know when to make them fire? Exactly, the crankshaft position sensor. If you had a bad crankshaft position sensor, which cylinders would be affected? All of them, right? So just boom, make sure you got this. Like don't get off track where it's like I have a misfire in cylinder 3. I think it's the crankshaft position sensor. Like, no, that doesn't make any sense. If you have a crank no start, that does make sense. If it cranks, but it never starts, you could pull the coil out and you could be like spark test number 1. Yeah, that's got spark. Spark test number 2. Yeah, that's got spark. Well, it's not ignition related. Or no spark, no spark, no spark. If it's got no spark on every coil, I'm going to say you more than likely don't have 6 bad coils. I'm going to say more than likely. I'm not going to say impossible though. So I'm still going to do some due diligence and make sure that I test it. But I'm probably going to put that pretty low on the priority list of tests to do, is test every single 6 coil. I'm probably going to start looking at that crankshaft position sensor right away. All right, so here we go. You ready? Let's go back in time because we talked a lot about how to diagnose the coil unplug, but now we're gonna get some prior perspective. If the car came in with a misfire or stumbling, poor idle, fuel economy, they'd be like, oh yeah, you need your tune-up. You're like, okay, tune-up. Spark plugs, cap, distributor rotor, spark plug wires. If it was an older one, you do the points and the condenser. These were wear items, so we'd be doing them all the time. It's important you understand the perspective. We used to be doing tune-up stuff all the time. So let's say back in the day, they might call for that at 12,000 miles or 12 months. So every year, you're going to get a whole bunch of ignition parts thrown on the car. And that was, the parts were cheaper, but everything was cheaper back then. It wasn't real efficient, right? So then as they went to, a little bit higher quality and they got rid of the points and the condenser, maybe it's a distributor ignition system, but with no points, that might be like a 24,000. So you see, this is really just showing you what needs to be done when. So when they were due at 12 months, 12,000 miles, That was back in the day with points condenser plugs, wires, cap rotor. But then when they got away from the points, it'd be like 224, 2 years or 24,000. Then sometimes 336. Then once we got into like no distributor, we end up with something like this. Can you guys see when the spark plugs are actually due? 100,000 miles. 100,000, 120,000, pretty normal right now. If it's a coil on plug system with platinum or iridium or some sort of precious metal laser coated fancy spark plug, you're probably 100 to 120,000 mile service interval under normal use. So now if the car comes in with a misfire, I'm not going to be like, yeah, it needs a tune up, right? Because the tune up is gone. The tune up was like, it needed every year or two. Now it's like, no, we don't really need that for 100,000. What I see a lot of times the coil fails before the spark plugs fail. Now, if I diagnose it and the coil's no good and I replace a coil, I really should replace the spark plug that was associated with the coil, because that spark plug's gonna be all fouled up because it wasn't sparking, it wasn't burning. If I'm gonna do one spark plug, I'm probably gonna do four, but then I'm gonna weigh in like when are they due and when were they done? You know, there's some things to weigh out, right? So back in the day, we were doing a whole lot of maintenance. We were just doing a ton of maintenance. In current, when we're dealing with this is the whole direct ignition system, coil on plug. The wear items there are none. The spark plugs, but the spark plugs are good for 100 to 120,000. There's no spinning parts. There's no rotating parts. You've got the ECM. That's pretty reliable. You got some wires. Wires don't fail unless there's something wrong. If something chews them, if a two-legged varmint, that's us, pokes them the wrong way and ruins the insulation, and now water gets in it, corrodes it, right? If the wires fall on the header because you absolutely had to have the header to go bang, bang, and now your wires are laying on the header and they get burned up, right? If you leave the car pretty stock and everything's routed the way it's supposed to, there should be no problem with your wiring harness, like ever. Accidents, these types of external issues cause problem with wiring. So if the ECM is reliable and the harness is reliable, the coils are fairly reliable, but coils do fail. This is probably going to be the number one failure on a coil on plug modern day current vehicle. The coils are probably the most common. Maybe followed by, if it's got a bunch of miles, maybe the spark plugs. But I'm actually going to show you how to really diagnose spark plugs. Generally, we're just going to do the spark plugs when they're due based on the miles. If your spark plugs were due at 100 and the car's got 200 and it's misfiring, it may very well be the spark plugs. But because we came from the era of tune-ups, a lot of times, every time somebody gets a misfire, they're like, oh yeah, I need spark plugs, put spark plugs in it. So, you know, spark plugs tend to be kind of still over-maintained just because people are like, oh no, spark plugs don't last 10 years and 100,000 miles. They last 1 or 2 years. Like, no, not the $15 NGK iridium coated. Those are 10 years and 100,000 miles. Right? So just weigh all that out to give you some good perspective. And then we'll, get into like how it was, how we test it, how it is now. So if it was a distributor type system, this is the underside of your ignition, your distributor cap. So we had these little contact points. You guys remember that from last week, how we saw the distributor spin? These would get corrosion. These would get arcing. I got a picture of carbon tracking, right? And this little center one, that's where the high voltage comes from the coil. That's like spring loaded. That one would wear because it's pressing on the spinning rotor. This thing would wear out. There's moving stuff, spinning stuff. It would just wear out. If it was even older and it had the breaker point ignition, that would really wear out, like a year. And then this one is more of an electronic ignition. So they made the breaker points electronic, but you still have these spinning parts. That's going to wear out. So we're going to do that one as a maintenance, right? And that's kind of what we're looking at here. So a big part of it is just replacing these as a maintenance. If your vehicle has a distributor cap, we're probably going to need to be doing that. It might be 30K though. And maybe even up to 60 if it's got platinum spark plugs, but I don't think the distributor cap and rotor are going to last 60K. I doubt it. right? And then one of the things that we'll do pretty commonly is set the timing. So if it has a distributor, this is a little bit more about service, more so than maintenance. But let's just say, California, did you know they have to verify the timing on a vehicle when you get a smog if it has a distributor? So on a newer car, the computer controls the timing. The computer monitors the timing. If there's something wrong with the timing, the onboard diagnostic system is going to set, a crankshaft, camshaft correlation, or, get a set of code. But on a distributor, the timing was controlled literally by where the technician sets it. So if it's a car that has an adjustable distributor, that's one of the checks for smog. They're supposed to connect their timing light. There's actually discussion on who did the set timing discussion. I think Ronnie did it. Mason did it. I remember seeing your name. That's a fun one. Just to that takes you back in the day. Who knows about duck hunt? Okay, the duck hunt gun, that's what the timing gun looks like. You hook it up to cylinder one, you hook it voltage and ground, and you literally shine it down there and you see where this little line shows up. And if you turn the distributor, it'll move the flash one way or another. And you're just literally using this duck hunt gun. It's very mechanical. It's cool. You guys you'll do the discussion. There's a bajillion videos on setting timing. But to do it, you have to usually initiate it. So like, for example, you might have to disconnect this. Or sometimes you have to ground something. Or if it's a vacuum type, you'd have to disconnect the vacuum line. Or there's some way to set the base ignition timing. You don't just start like adjusting. Okay, so you reference the service info and be like, all right, disconnect this or connect that or whatever the heck it says. And then you'll actually do the adjustment. Cool. So setting the base timing is something where we could talk about it for an hour, but I really want you to watch the video. But this is an ignition type service. Okay, makes sense? That'd be a fun one. You get to use the duck hunt gun. Although we could do it as a demo, but I don't know if we actually have a car that has a distributor. They're old school. So we'll think about it. What about spark plugs? Ooh, well, they're one of the primary causes of failure. I would say with a modern system with those really high quality $15 spark plugs, they're probably not the most common, but they're still one of the most. Now, why do we replace them? Well, a lot of times because of fouling. So what is fouling? Well, fouling is like a deposit. It could be oil fouling. It could be fuel. There's even coolant technically can do it. And that makes it so that the spark plug will, like it says, it should build the spark and go through the center electrode through the insulator and then jump the gap, right? But if it's fouled, instead, the fouling will form a conductive path to ground. Well, think about what that means. Spark is like water. It takes the path of least resistance. Water is like college students. They take the path of least resistance. So if we were to say, hey, we're going to walk out to the shop, who is going to go out the back of the building and go around this way, and go up and over the hill, and then go down the shop? Nobody's going to do that. That's just not your nature. Now you have free will and spark doesn't have free will, but I'm just letting you know, if the spark can take a shortcut, I promise you it will. A lot like water and a lot like students. So if we have fouling right here and we have oil that's actually making a conductive path from the center electrode out to the ground, guess what it's not going to do? It's not going to put forth a whole bunch of effort and jump the gap, which means the spark plug is not going to spark, right? Because the fouling, the contamination on the surface makes a conductive path to ground, and that's it. So you have no spark. How do you fix it, though? There are more than one way. Back in the day, I wouldn't do this because labor is expensive compared to spark plugs, right? But back in the day, they used to have a little sand blaster, and you could put some sand in this little pouch, and you could screw the spark plug onto it, and you could hook it up to an air hose, and it would basically sandblast the spark plug. It would just clean it up. That would fix the fouling. That kind of cool, huh? You know why we don't do that? Go ahead. True. If it's a coated spark plug, that's ruined right there. If it's an old school basic spark plug, that would repair it. But the thing is, if it's a basic spark plug, those are $3. So like, what are you doing? you're billing the customer $100 an hour when the spark plugs are $3. Like, stop that. You can't do that. It just doesn't make sense. All right, so we don't really do that, but it was a cool thing that you should know. So you know what we're probably going to do? We're going to replace them. If the spark plugs are fouled, you pull them out, you look at them. It's on the next slide. They're fouled, you replace them. But that's not it, though. The spark plugs also, over time, they wear and the air gap increases. So you know what that means? You know how the spark plug gap is a set number? Well, like when you think of a spark plug, you don't think of it wearing out. Nothing's touching it, right? But believe it or not, that arc and arc and arc and arc and that high temperature and fuel and, you know, turbulence in there, the spark plug actually will wear the metal away and the gap will get bigger and bigger and bigger. If that's the case, we don't try to bend the gap back up. We replace the spark plug. So, right. So when we're looking at that, that's some of the reasons we're replacing them. Now, does it start to make sense why if we do the iridium coating, that's very, very hard, platinum or something, that's gonna decrease the amount of surface wear, which means that gap should stay good a lot longer. And that's why we don't need to replace them much. But if the spark plug is fouled because the coil failed, it doesn't really matter that it was iridium coated and the gap is good. We need to remove that conductive path without scraping off the iridium. That's probably not going to work. We're going to put a new spark plug in there. You follow the logic there? So that's what you got to be thinking about. All right, so if we look at this, you can see, you know, without detail, right? If you guys want, we even covered how to read spark plugs earlier. You can look up, there's many charts. Carbon fouled. If it's carbon fouled, it's maybe rich mixture. The timing is too retarded. The low compression, too cold of a spark plug. If it's oil fouled, that means there's oil getting the cylinder. You guys remember the very first unit, we checked mechanical engine. If you had worn rings, oil gets up in the cylinder, right? Oil is going to foul that spark plug. Okay, I like to pause on that one because that's one I see a lot. We were talking about, oh, if it's got a misfire, it could be because, you know, the engine's got 200,000 miles, it's worn out. Well, yeah, I mean, that engine's done a lot of work. You know what I'll guarantee you that 200,000 mile engine does is burn oil. When the oil goes around the spark plugs, it ends up in the combustion chamber. It ends up on the spark plug, doesn't it? I just noticed I gotta change my mic real quick before I lose it. If that oil ends up on the plug, why do you think that's a big concern? Speaking of fouling, why do you think that's such a big concern? It's going to be fouled. Make sense? So when we're talking about these iridium spark plugs, oh, they're going to last 100,000 miles. Yeah, they might last 100,000 miles, but if the oil passes the rings and coats it, they might last like a month. Make sense? So if we have an issue with the engine burning oil and you pull the spark plugs out and you can see that the spark plugs are fouled by oil, what do you think the real fix is? Oh, I know, throw another pair of spark plugs in there. And then throw another one and another one. So when somebody says, yeah, I need to replace my spark plugs every 3 months or something, and I'm like, nope, I don't think so. And they say, yeah, when I take them off, they're all black and coated with oil. I'll be like, oh, well, that's not really addressing the problem though, right? What do you think the real problem is?
Blow-by.
So what do we need to do to fix blow-by? Don't you tell me I need to rebuild the engine. I don't like you anymore. Tell me good news. I only want positive people. You're toxic. You're a downer. Like, give me people who are gonna make me feel good.
The good news, you get a new car.
Oh, but do I have to pay for it?
Not if you go to the dealership where they got it fast.
Okay, you're a dangerous friend. You're a dangerous friend. But that's kind of the thing. But like our job is to not be emotional, right? Don't be like, oh yeah, we're friends, cry on my shoulder, like it'll be all right. Just throw one more pair of spark plugs in. Like you're looking at spark plugs, they're covered in oil. You got to know where'd that come from. That's your job. Be like, if the spark plugs are covered in oil, it's the engine's consuming oil. We could do more advanced testing and find out is it valve guides that are worn or valve seals or piston rings or worn cylinders, whatever. But either way, that's going to be a lot more money than spark plugs. And you wonder why nobody likes automotive technicians. We give them the bad news, but we give them the truth though. That's your job. All right, and then you can see, I mean, there's even other ways to read them: lean mixtures, foreign particles, et cetera, right? So when we look at these spark plugs, they're going to tell us a clue. They should last however long they're designed to last, 100,000 miles if it's a iridium plug. But if they're not, we got to start to deal with the source of the issue. Now, when we go ahead and we work on these spark plugs, just notice, look at these sockets. Those are spark plug sockets. What's special about them? Well, they've got a little a rubber insulator in there that's going to help prevent spark plug from cracking during installation or taking it out. But if we're taking it out and we're throwing it out, who cares if it breaks? But if we're taking it out to do a compression test to put it back in and it's broken in two pieces, now somebody has to pay for that spark plug. Make sense? And they have a lot of different types. My favorite one is this one. You see how this one's kind of longer? You remember that coil on plug? It's the spark plug's way down in the tube. This is nice. You could make it work with one of these, but you got to put an extension on it. And if you put the extension on the socket and then you put it down in there, you crack the spark plug loose, and then you unthread it, you go to pull it out, and the extension pops out, and the socket's still down in there. And then you're kind of like, come out. Then you're get out of there, get out of there. Right? This is a nice tool because this can't pop off from there. Right? So right here, all one piece, that's nice. But this might be a $40 tool. So you got to weigh out, like, am I going to spend the $40 and have a nice time doing the spark plugs, or am I going to just make it work and save the $40? Up to you. Depends. Cool. So that's a lot about spark plugs. Oh, and if we have to gap them, gapping is a thing that we don't usually spend a ton of time on. And the reason we don't spend a time on it is because we don't really do it that much on a modern car because it's got that laser coating or some sort of an iridium coating. If you go to gap it, you're going to scrape the coating off. So we usually don't. But if it's an old school spark plug, you could do the gapping tool. If it's a good gapping tool, it should reduce the chances of damaging the electrodes or the insulator. But again, if it's a long life spark plug that's coated, no, we're not going to gap it. If the gap is messed up, it's getting replaced. But you can do whatever the heck you want, I guess. I'm just here to tell you how you're supposed to do it. All right, cool. And then when we talk about the distributor cap, like if you look right here, you can just barely see there's this weird trace. That's where arcing and stuff has been occurring. So if you see carbon track, that kind of tells you like the high voltage is not going from here to here like it should. It's arcing to other places. A carbon track is indication that, we've got it's finding another path to ground. So like what we talked about before, the electricity is going to take the path of least resistance. So if you have a lot of corrosion on this terminal and it becomes actually easier for that high voltage to arc through the cap to something else, it will do so. So if you're finding that it's arcing to the wrong place, it's because of one of two things. One, it's become too easy to go to ground. So like, for example, if you had a spark plug wire that was laying on an exhaust manifold or a header, that's really easy path to ground, right? The spark is going to go that way. But because there's not enough resistance, right? There's low resistance. Low resistance is really easy. But it could also be that there's really high resistance in the path. So if it goes to leave the cap, it goes to this center part, right? And then the rotor carries out to one of these. If this is corroded or that spark plug wire has a lot of resistance, or your spark plug gap is really big, that's all resistance. It's going to be like, you know what? I don't want to go that way because it's too hard to go that way. So instead, I'm going to start arcing through the cap and find a ground right here. That would be a clue, right? So we're detectives sometimes. Arcing could be because it's too easy to get to ground and it's going to go where it's easiest, or it could be because we have high resistance electrically in the circuit and it doesn't want to make it all the way to the spark plug and jump the spark plug. Okay, make sense? Just to give you some perspective on where we're going. And then of course, if it's carbon tracking, we're going to replace the part, but also there's probably a reason it was carbon tracking right here. So we probably need to find the real reason, which maybe it's high resistance in the spark plug wire or a big spark plug gap or something. And then here's another type of cap. I kind of like these because they're flatter. Sometimes the caps like this style comes out the side, But back in the beginning, there was one that comes out the top. They're just different styles. It's not a real big deal. If you go to do one of these, it can be hard to tell which spark plug wire goes to which part. So my rule with this is going to be, you go to change this cap, first off, you're probably going to do more than just a cap. But if you're going to pull the distributor out, or you can do just the cap or whatever, you need to mark stuff. I can't tell you how many times someone rips all the wires off, and then they're not sure exactly where they go, and then they do their best to get them back on, and they have two of them switched, and now it has a misfire. Or if you switch a certain two, you'll go to crank it, and it'll actually spark the spark plug that's on the beginning of the compression stroke. It'll try to push the compression back down, and you'll go to start it, and it'll be like making horrible sounds. You're like, what is that? Well, that's like a spark plug cross leak. That's a crossed up wire, a wire that's going to run to the wrong place. So if this is not rocket science right here, what would you do to make sure you get the wires back where they go? What would you do? How? A number with what? How would you write it? You could do that. Tape is good. If you got a really good Sharpie, it can be good. If you try to use a regular pen, you're probably going to wipe it off the first time you touch it and be like, oh no, so paint pens, there's some different options. I agree. Make some marks. That's it. This is not really rocket science. Okay. And then there's another part that I didn't decide to cover, but it'd be something for everybody. I don't want to cover a ton of stuff on distributors because they haven't been around in 20 something years. That may have a distributor, but it may not. Tough to say. We'll find out. So one thing you should all know how to do is, if you do have to pull a distributor out, and then you go to put a distributor in, there's a particular way to set it up. You need to actually find out. Let's just say, for example, you see this upper one right here, this one right here. Let's make that cylinder 1. I think it actually might be. If that's cylinder number 1 and you had to pull the spark plug, you had to pull the distributor out, when you go to put it back in, you're going to take the cap off. Underneath there's a little rotor. Remember it from last time, the pointer? You're going to make sure that the pointer is pointing towards cylinder number 1. Okay. Then when you go to slide it back in, you have to have your engine turned with your little screwdriver in the spark plug hole or whatever to cylinder number 1 at TDC. You remember that? Cylinder number 1 goes to top dead center. Right there, top dead center of compression, not exhaust. If it's at top dead center of cylinder 1 on compression, isn't that when the spark should occur? Good. So we're going to make sure that that's the case on cylinder 1. And then we're going to make sure that this pointer is pointing to cylinder 1 for that rotor. And then boom, you drop the distributor in, and your base timing, you're close. Right. And then from there, you can move it a little bit, but it splines in on a gear. So you can't turn a whole circle. You have to have it TDC cylinder 1 with the rotor pointing at 1, and then drop it in, and then you can fine tune it after. Okay. It's not something that we do, but I did have a student go through the whole program, was really good on new cars with coil on plug. And then he went for a job interview at the post office, and you know what they still use? Old school 4-cylinder distributor engines. And they said, yeah, for your practical test, go ahead and set the timing on this one. And the distributor was on the bench, and he was like, I don't know how to do that. And they're like, what the heck kind of mechanic are you? And he's like, we don't do this. So I don't want to spend a ton of time on it, but like, at least you'd have a basic understanding. If I were to spend just a few more minutes, maybe he would have got the job, but he had no idea how to do it. But he's at a Lexus dealer, and he's doing pretty good anyway. So it's just a blast from the past, if you will, right? Now, same with wires, like same recommendation, make the marks. But there's a couple things that I must add. If these spark plugs have damage, like maybe it rubbed on the exhaust, or maybe a mouse chewed or something, these secondary spark plug wires, secondary ignition wires, they can't have any kind of damage. All right. So who has ever taken their car through the car wash, washed under the hood, and afterwards it wouldn't start? Mason, is that true? All right. If it's an old car, I can tell you most of the reason why. Remember how water is a decent conductor, right? So if you have spark plug wires where the insulation's kind of broken down and you have a cap and a rotor that are not sealed real well, especially on those Hondas with the distributor from the side, anytime that you get water on there, it's now saying like, hey, remember path of least resistance, the spark, the secondary voltage is like, you know what? I'm not going to go all the way through that wire and then jump a gap on the spark plug. You know what I'm going to do? I'm going to exit right now because now there's water there and it's made the path to ground easier. So all your secondary ignition voltage just goes through the water and it arcs to ground right there. If your spark plugs don't spark, what's the car no longer do? Bingo. So how do you fix it? Come back tomorrow. Yeah, dry it. I mean, if you could really dry it, yes. But a lot of times what we'll do is just be like, oh, whatever, I'll come back tomorrow. And tomorrow starts and drives fine. Then you get these concerns where it's like, my car has a stumble and a misfire, but only in the rain. And my car runs good on sunny days and it runs bad on wet, rainy days. And these types of things would be like, well, there's a good chance that it's something like these secondary wires or the cap or rotor that have some breakdown of the insulation, and as soon as they get wet, that's just enough to make it arc right here to the valve cover or something. So you want, it probably is exactly your Jeep. Yeah. So do you want to know your heap? The J is silent. I don't know if you knew. Heap. Yeah. Heap of, well, we'll move on. All right. So if we're looking at this, you want to know how I would test it? Of all the tools and all the specialty items, I like the KISS method. So I'm going to test it with Windex. Or actually, I'll just take the Windex bottle. I'll put water in it, but Windex would work too. And I'm going to literally mist Windex or water in a spray bottle on these wires. And if it's running, I'm going to do it while it's running. And if I missed it and all of a sudden I see a little arc right here, bap, 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 you can hear it too. It sounds like a crisp snap. Crack, 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 crack. I'll be like, oh yeah, your wires are no good. How did I test it? All I did was I made a potential conductive path to test the insulation. Was it fancy? No. Does it work? I say yes. And so I would do it. And then if I do that, I'd be like, yeah, you need wires. And if you can do wires, you probably should do the cap and the rotor. And you probably do the spark plugs. How many years has it been? Oh, it's been 4 years. Yeah, these are due every 2, right? It's old school, taking you way back in time. I basically replicate what happened at the car wash. That's what I do.
I just replaced all of my wires.
And it still does the same thing, or afterwards it's good?
Now it's fine.
Bingo. So you diagnosed it by going through the car wash. It's all right. We can replicate the car wash with the spray bottle. And then another thing I'd like to point out is, when it's a cap from the top, it's nice if the cap is marked, but sometimes it's not, right? So just take good pictures and make good notes when you go do this type of work. And then you see how they're held in this routing retainer, like these two? Those are nice because it's going to make sure that the wire doesn't rub on the valve cover over time. If it rubs on the valve cover and it wears some of that silicone insulator away, that's a path of least resistance. It's going to arc into that valve cover. So we keep these secondary wires or these high tension leads or spark plug wires, same words, right? Same parts, different words. We keep those away from problems, especially the exhaust. Okay, cool. And then we go to replace them. You can usually pull on them, but if anybody's going to pull a spark plug wire today, I'm going to warn you right now. If you grab it by the wire and you yank on it, it's probably going to rip the wire out of the boot. And again, like normal, I can tell you, ask me how I know, but I think you already know. The mistakes you are going to make are the mistakes I already made. I just don't want to learn that lesson again. I've been enrolled in the School of Hard Knocks for long enough. I even lost my hair over it. I'm not trying to do it anymore. These pliers are pretty nice. You can grab them and you can twist them and you can pull them off at the boot where it's kind of stronger, right? But the other thing is, I'm going to tell you, I have a pair of these that are even cooler that have a little wire, and the wire has a little alligator clip, and I can clip them to ground. So that way, if I want, I can pull spark plug wires off while it's running and not lose any more hair. I don't have much left. I have to retain this. So if I pull it off and the path of least resistance is no longer through my body, it's through the little lead that's connected to ground, it'll actually not shock me. That's nice. I like that. But for you guys, I don't think we're going to do that today. I think you're going to be pulling any spark plug wires off with the engine off. Okay, makes sense. But this is a good way. And another tip would be dielectric grease. You guys ever heard of dielectric grease?
Yep.
What's it do? That's actually true. So a dielectric is an insulator. And so if it's an insulator, that means it won't flow electrically. Make sense? So if it's a proper good insulator, why do we want it then? I mean, it's adding resistance to the secondary ignition circuit. But this is the thing though. The secondary ignition has plenty high enough voltage. If we put just a little bit of dielectric grease in here with like a Q-tip or non-generic cotton swab, that's going to help this boot slide onto the spark plug or onto the cap or whatever. And then the metal to metal is going to scrape the dielectric grease and have a nice connection. But that dielectric grease also functions as like a waterproofer, right? So it's nice. Exactly. So if you're going to be like a good, detailed mechanic, put a little dielectric grease in there. They'll slide on easy. They'll slide off easy. Whoever works on it next will be like, whoever worked on this before, I like them. If it's you, you're going to like yourself. If it's not, if you don't use the dielectric grease, you're going to hate yourself, and it causes a lot of issues. And there's treatments available for that. But that's not what I do. All right. So this is just a good way to do stuff. But just understand, the dielectric grease does not make the conduction better. It doesn't. It's actually the opposite. We use it as lubricant and a waterproofer. But as long as the system's in good condition, the dielectric grease won't be a problem for that secondary voltage. So sometimes I see in the forums, people are like, oh, if you got a bad connection, yeah, take it out and dielectric grease it and put it back together. It's like, that doesn't make a better connection. If you were to do that, it makes it worse. If you were to do that before, that would have kept the water and the corrosion out and it would maintain a better connection. Yes. But once the connection's corroded or rusty or whatever, the dielectric grease ain't helping. Okay, makes sense? We got to actually make sure the conduction is good first. Cool. And that's pretty much what we're saying. And then right now we'll get into coil failures. And I want to address something that was said earlier, which was a good answer, but a bad answer. It was a good participation, but it wasn't helpful to not damage coils. A coil failure is excessive stress from secondary ignition resistance or open secondary circuit. Let me explain what that means. Your coil has to work harder when there's more secondary resistance. Think of secondary resistance on the meter. You could be like, hey, it might have 4,000 ohms. But how many ohms would it be if it's a full-on open? OL, which our typical meters measure up to millions of ohms. If it measures up to millions and it's out of the limit of the millions, that means it's billions, whatever the number. It's a lot. Mucho, mucho, macho. Right? That a lot. That's even harder on the coil. Okay. So when not the primary side, but the secondary side. So if you have an open secondary, like for example, this spark plug wire is cut and it's totally disconnected, your coil is going to try as hard as it can to jump that gap. It's going to try as hard as it can the entire time until that open is repaired. Make sense? So remember what we were saying, we could pop the coil out and we could set it up there and let it arc. That's essentially an open, right? That's going to make the coil's job so hard, it's damaging the coil. If you do it for a few seconds, we're good. But I had a class at one point, they went to diagnose a vehicle that belonged to a staff member of the school, and they pulled the coils out to do their testing, and they cranked and cranked, and they did measurements, and they cranked and cranked and cranked, and they ran it, and they did this, and they did that. They actually killed several coils in their testing. So when a coil's completely disconnected from the spark plug, it's going to try to arc wherever it can. That hurts the coil. Understand? Yes? So let's do it as a diagnosis, but don't do it too long. Okay. Or better yet, if you use the spark tester, that's even better. All right. So now let's go to what else could cause it. So the firing voltage needed to create a spark plug across the plug's electrodes depend on the electrical resistance of the spark plugs, the wires, or springs. If it's coil unplugged, they don't use wires. They might use like a little spring or a boot or something. The size of the air gaps at the spark plug, the rotor distributor cap. So if you have a whole bunch of worn out, high resistance spark plug wires, that's hard on the coil. If you have spark plug gaps that are big, that's hard on the coil. If you have corrosion on any of the connections in the secondary ignition, that's hard on the coil. Right? You see where where this is going to help you understand. If a coil failed, it could be because there's excessive secondary resistance that made the coil fail. Make sense? So if we go ahead and we do the coil, if it's a coil on plug and we replace the coil because the coil was bad, yeah, I agree. It's you need to at least inspect that spark plug. If that spark plug has a big air gap, that's putting more strain on the coil. Makes sense, especially to get prematures. Premature coil failure would be caused by high resistance. So this is just a visual on how we would check it. We would check resistance, like continuity of the spark plug wire. Typically, it would have maybe 4,000 to 6,000 ohms per foot. So if you have a 1 foot long spark plug wire and it's 5,000 ohms, that'd be good. But if you have a 1 foot long spark plug wire and you have 10,000 ohms, that spark plug wire is not good. And if you don't replace that spark plug wire, it's going to put premature wear on your coil. Make sense? Now you kind of see why we would do tune-ups as like a whole cap rotor, wires and plugs. We'd throw a bunch of stuff in it and it'd be good for a while. And we'd throw a bunch more stuff in it, it'd be good for a while. It wasn't real common that we do a coil and not the cap, the rotor, the wires, the plugs, because secondary ignition resistance would be potentially the cause of why the coil failed prematurely. Now coils do fail over time anyway, I acknowledge. Okay. So we can measure that and inspect that. But also, like it's saying, worn spark plugs, that'll cause it to prematurely wear. On the coil unplug, when you guys pull those off, just remember there's a boot and a spring or sometimes like a terminal or whatever. If you pull that out and you see that it's corroded, that's going to be a failure point right there, right? If the spark plug has a big gap, that's going to be a failure point. So when we are doing this service, you just have to know there's a correlation. Electrical resistance, which includes a big spark plug gap, will potentially cause premature failure on the coil. Okay. And then of course we get a shorted coil, which would mean it's gonna short internally. So we've seen where like the coil is arcing outside, but they can also arc inside because your coil is bolted to something. And usually the thing it's bolted to is metal. So if the coil shorted, it could be sending its secondary voltage right through the short. It won't spark. It'll just send all of its voltage through the short. And that would be either a misfire or a no start. And then we got one more thing, a coil driver. So a coil driver is the thing that makes the coil fire. So if it's on a modern system, that's the ECM. If it's on a little bit older, that's the ignition control module. If it's even before that, you know, we get into the points and stuff like that, but the breaker points, but generally the coil driver in the ECM, you know, they can fail intermittently or they could be totally bad, but that's a potential for a no spark as well. So just be aware, it could be more than just the coil. Okay. And then, like I mentioned, if there's electrical resistance, it's going to try to bridge that gap and increase the voltage. So if you see high voltage, that's very hard on the coil. If you do it for extended amount of time, it's going to damage the coil. And that could, because your secondary is trying to jump the gap, it's putting a strain on your primary as well. It's not really good for the primary side either. Makes sense? And your primary side on a modern vehicle is controlled by the ECM, not less than ideal. Let's put it that way, less than ideal. Cool. And of course, talk about corrosion, moisture, oil leaks, water intrusion, right? So all these weather functions, all these aspects of weather can damage your coil. Make sense? So like, let's say You have a cool Jeep and you like to take it mudding and off-roading and go through all these puddles. That's going to be kind of hard on your coil because your coils are getting splashed and muddy and wet, and you know, all that stuff can have an effect on the coil. If the coil's in really good condition and it's sealed, it should be all right. But just know you're putting some stuff under some stress with that. And similar, like oil leaks as well. Oil leaks will break down the insulation on the spark plug wires and stuff. Okay, so now let's get into just the beginning of testing. If we look at this coil, here's your diagram. All right, we've got 12 volts coming off the battery or source voltage, goes to the ignition switch. You've all heard it. We talked about this. When you hear the term "turn on the ignition," what that literally means is turn the key. But what it actually means is turn the key so that you close the switch so that your ignition coil gets voltage. Do you know what that's what that meant? Yeah, when you turn the key on in an older car that was carbureted, it would literally just give power, positive voltage, to the coil. And that would mean it's ready to start, right? So when you see the movies where they're hot wiring vehicles, honestly, all you needed to do was get positive voltage from the battery and send it to the primary of the coil. And that car would run right now. That's what hot wiring was. So in the old movie, when they're sparking and arcing, that's Hollywood. That's fake. But if you actually, now I'm not sure why you'd want to do this. All right, let's just say, make you the hero rather than the thief. Let's just say there's a person who's hurt. You find them out in the middle of the trail, and you're like, there happens to be a truck right there, and you want to save their life, but you don't have the keys to the truck. If you were to go over and you were to just make a jumper from the positive terminal to the positive of the coil, that truck would start and run. It's old school, right? That's a good hot wire. Am I right?
1988 Toyota van.
Oh, that'll do it.
Yeah, there was I forget what the problem was with starting it, but my father-in-law did that. He hardwired it to where you to turn the key on and then go under your car and
make a connection,
connect it to the alternator, and it would spark it.
Zoom, there you go. So those are fun, but doesn't that sound kind of easy to steal? So then they got into the key locks the column. Then they got into like, you know, then once we did fuel injection, you need to do more than just power the coil. You got to understand. You need to do more than just power the coil. You need to actually power up the control module. You need to give voltage to the injectors. You need to power up the fuel pump, right? But back in the carbureted days, it was literally just power the coil, okay? So this coil is going to get 12 volts anytime the key is on. Everybody clear? That's why I told you that. Do you know what's going to make the coil fire based on last week? Pulsing the negative. Remember that? We would make a connection. So if this negative is connected through the switch, breaker points, or transistor, that would charge the coil. How do we make the coil fire or induce the voltage into the secondary? Do you remember? Take the ground away. Give it the ground, take the ground away, starts the spark process. So look, if we wanted to test it, and I do have a video that I added on testing ignition systems, all we really need to do is see if the coil is getting its negative pulse, right? So a neighbor had, you know, a dude working for him, and he had an old Toyota truck, like an 88 or so Toyota truck, and I heard him go down there and go to crank it, and it's sha-na-na, na-na-na, na-na-na, and I'm like, oh, bummer. I'm trying to remember his name. Juan, yeah. And he was like, sha-na-na, and I'm like, yeah, let me go help him out. So I said, hey, ¿qué pasó? It's marche, sí? Yeah, marche, right? It's cranking, but no start. And I just said, okay, you stand there. I brought one basic tool, I'm going to say it was a test light, but in reality, I used a power probe. I love power probe. Power probe, my go-to. Power probe is like Spider-Man. With great power comes great responsibility. The power probe is like a test light, except you can also power things. And if you power things that are supposed to be grounded things, you let the magic smoke out and they don't work anymore. So power probe's not what I usually throw students on. But if you're just looking at a test light, all the test light does, the test light connects. You'd connect the test light to positive, and then when you come over here, if you touch the test light to negative, that's going to make the light bulb glow, right? Because it goes positive through the test light to the negative. So all I'm doing with this test light is I'm looking for a pulse of ground, right? Because when we go to charge the coil, we give it ground. When we go to spark it, we take it away. Cool. So I go down there with one tool, test light, power probe, test light. I put on there and I say, one, start it. And I look, and what should I see? Flashing. Exactly. Flashing. Boom. Flashing because the triggering device should give ground and take it away, give ground and take away, give ground, take away. You know what I saw? Nothing. I just like, there's nothing. There's no flashing, no nothing. And I was kind of like, all right. You know, because he was ready to go get a coil and the spark plugs and the wires and the fuel pump. And I was like, no, let's just do basic diagnosis, basic. You give me 5 minutes and I'll tell you what I think, right? So look, it doesn't flash. If it doesn't flash, where do you think we would check next? What is this thing? In this case, it's a transistor. Yeah. So the transistor pulses the ground. Where is it located? Inside the ignition control module. But if it was breaker points, we would check there. If it was, in his case, it was a distributor that had a pickup, a distributor ignition pickup coil. And so I was like, well, let's check the pickup coil. That's under the distributor cap. Pop the cap off. And you know what we found? That whole ignition pickup, which is like a coil of wire, where that little arm comes around and it triggers the sensor, right? Big old bundle of copper all hammered. It's like, oh, Juan, you go to the store and you get the distributor. And he's like, the distributor is a little expensive. I said, no, I know, but that's what's wrong within just a few minutes of diagnosis. Make sense? He didn't want to buy the distributor. He wanted to buy the spark plugs. Were the spark plugs going to fix it? No. As tested really quick, down and dirty, with just a test light, with the most basic $6 tool. At least you know if it's on the primary ignition side with the trigger, or you know, if it's not getting voltage because the ignition switch or a fuse, right? It was easy to check with just the most basic of basic tools. Okay, so from there, that's the most basic test of the primary ignition system. We're going to do a few more tests on the coils. Like, for example, so you know, you can actually measure resistance. So if you wanted to measure ignition primary, right? Primary is the small wires. Because let's look at it this way. Like, I tested with the test light, right? And it was getting no pulse of ground. So I knew it was triggering a problem. But what if it was getting a ground pulse? And what if it was getting voltage? You know, that would kind of tell me that the coil's not working. But another way I could test it is to actually measure the primary winding of the coil. So where do you think we're going to have our meter set if I have the positive, the red lead on the positive, the black lead on the negative, and I'm trying to measure resistance of the primary winding? What setting do you put the meter on? Ohm's resistance? Yeah, bingo, you got it. That's an easy test, right? You just literally go to the primary positive and the primary negative, and you measure inside of the coil. What if this coil was open? What would it measure? OL, yeah, bingo. If it measures open, remember, we're trying to prove the fault, prove what's wrong. If we measure the primary ignition coil and it's open, it's no good. That's it. And you're like, yeah, it's a coil. And they're like, are you sure? And be like, I can guarantee you 100% this primary ignition coil circuit is open. Here's the reading, OL. That'll hold up in court. That'll hold up with the manufacturer. That'll hold up with an insurance company. It's all good. That'll even hold up with somebody who's brings their mechanic friend to see if your work is good. And you're like, well, what'd you do to test it? I measured the primary ignition voltage of the coil and it was OL. Okay, that's a matter of fact. So this isn't really your opinion? No, because it's a measurement and it's out of spec. Have a nice day. Okay, so pretty good. Also, we could do secondary resistance. Now, this is a little different. If you remember on the coil, there was the primary coil, which is over here, right there. That's the low voltage one. Then there's the secondary coil. We can actually measure the secondary coil as well, right? Because ignition coils can be open. They can be open on the primary, measure the primary, but they can be open on the secondary, so we can measure the secondary. So like, this is actually measuring the secondary, but this is a little more practical for your view. This is the diagram, but this is the real life measurement. So if your coil pack is spark plugs 1 and 5 is the pair, right? There's a coil in there that does cylinder 1 and 5, like a waste spark system. You can measure secondary terminal 1 to secondary terminal 5, and that'll actually give you the resistance of the secondary coil. What if you were to read OL right there? What's that tell you? It's open on the secondary coil, right? An open on the primary coil means the coil's bad. An open on the secondary coil means the coil's bad, but in a different way. And we should document, right? You always want to be documenting just facts. That's it, just facts. Opinions aren't that valuable in this particular field. There's classes where your opinion is everything, but in here, not so much, right? So let's just do primary resistance, secondary resistance. You can do that in moments, right? How fast is that? Really easy. All right. Normally, 6 to 12,000 ohms on a coil. And this is mainly because the construction, sometimes it could be 15,000 ohms. If you can get the spec, that's ideal. Sometimes the service manual might not give you the spec though. And so you can use these as guidelines. Sometimes I look and I see no spec and then I measure it and I'm like, oh, well, the spec is never OL. The spec is never OL, ever. An OL means it's an open circuit. An open circuit won't do any work. It might be 6, might be 12, might be 15, not OL. However, there's another way, right? Because we're talking about opens, and an open in the coil is a problem, but there's actually a couple other things we could see too. How about this one? Low resistance or shorted. Whoa, that's kind of interesting. How could it be shorted though? Well, look, we've got all this epoxy resin or however they set these coils in. What if we had a little bit of a crack on one of these epoxy resins and we got a bunch of water in there? Water's a pretty good conductor, isn't it? So is that going to make it have higher resistance or lower? Lower, it's going to short it out. So if you were to go to do your measurement back here like this, and you were to get like 0.0 ohms, you'd be like, whoa, this has no resistance. That could be shorted, right? You could document it as shorted. So that does happen, right? And that's kind of what this is showing. Why would it be shorted? Well, I don't know, maybe physical damage, maybe manufacturing defect, a little tough to say. Those would be shorted windings. None of those will spark. An open won't spark, a short won't spark. They both need the same part, but the write-up would be a little different, right? And so when we do these measurements, maybe 3,000 to 15,000 on breaker point. Distributor, electronic ignition, 8 to 20. If it's electronic ignition, that's not distributor, maybe 8 to 15,000, right? The numbers depend on the system. Not OL and not 0.0, though, I could tell you that right now. That's a for sure thing. Cool. And then like what this is kind of showing is a conductance test is another type of a short, but it's not shorted between the two terminals. It'd be like you put your meter on the secondary voltage terminal, and then you put it on like the housing of the coil. Because let's just say that secondary terminal didn't get shorted to the across to the other secondary terminal. It got shorted to like the housing of the coil, right? That'd be like a short to the ground housing of the coil. So you actually have to go from secondary terminal to the housing, and then from secondary terminal to the housing. If you were to look at that on a diagram, that would be like this secondary coil getting shorted right here to the actual housing. Cool. A lot of times those housings are grounded. Not all the time, but a lot of times. Cool. So these are all tests, easy tests. What tools have we been using? It's the meter. You guys can use the meter, right? You can do all those tests. Okay. Now let's say we were talking about service a little bit. We talk about spark plug wires, but if it's coil on plug, we might just need to do the boot, right? The boot's just this little boot down at the bottom. It's not a hard part to do. It's, it's kind of like the failure of a spark plug wire, but maybe not as often because it sits out of the elements, out of the weather a little bit. But this boot could be a problem. To be honest with you, we typically don't do the boots. If the coil fails, we do a coil, which comes with a new boot. But it wouldn't be a bad idea to do a periodic maintenance of the boots I just don't know how many miles because the manufacturer doesn't usually call that out, right? You might just go in like preventatively and be like, let's do new boots, but you're on your own on that call. The manufacturer most likely won't tell you to. Cool, but it's a similar failure. All right. We talked a lot about testing the secondary with the meter, measuring resistance and stuff. Now let's get more into testing the primary. But this is a little tough because the way we test a distributor type primary is different. If it's a distributorless or if it's a coil on plug, if it's electronic, you know, there's differences. Okay, so this could be kind of quick, except because we have so many different types, we got to cover a little bit about each type, right? But again, if it's an old school distributor, that could use like a breaker point. That was really easy to test. You mostly test it by looking at it. But as soon as it goes into a control module, which means it's electronic, you can't look at an ECM and know if it's firing it or not. Now we're into measuring. This is where a lot of people will fall on their face and be like, I don't know how to test that. But they like the old breaker point stuff because they could test it by looking at it. All right, cool. So the best, just so y'all know, is a primary voltage waveform. That's going to give us the most information. That's going to tell us everything we need to know. But the way that we got to pull a primary voltage waveform is we go get the oscilloscope. We got to know where to probe. We got to make the connections. We got to set up the parameters on the oscilloscope to get us the right time and the right voltage and make it look right. Okay. But that one's going to do that one's going to tell us a lot of information. Okay. So keep that in mind because we're going to look at some waveforms. And then if we're measuring the primary is pretty easy because the primary is like low voltage. Sometimes it's good to measure the secondary, but the problem is the secondary voltage. Remember how that's like 20,000, 40,000, something like that. Your oscilloscope's not going to go for that. Your oscilloscope's going to be like, I'm done. I quit. Let the magic smoke out. You zapped it, right? So we're going to mostly focus on, at least for now, primary circuit, simply because it's easier for the oscilloscope to deal with. And a lot of times it's easier to actually connect to and measure, okay? Because those are the small wires, right? And also, this is crazy, but if we actually measure that waveform, we can interpret it to tell us if it's an ignition problem, a fuel delivery problem, or a mechanical fault. All right, so in my time, we didn't really get that good at these. But in the time before me, you know, without the scan tools and whatever, there are some old school techs that were like magicians. I mean, they'd bring out the big old sun ignition system tester, big old oscilloscope, but it wasn't even a digital storage oscilloscope. It was like mechanical, and they'd probe it up on a bunch of stuff, and they could look at the waveform and be like, oh, that cylinder has low compression, or that's a lean air fuel ratio, or that's a rich air fuel ratio. I mean, pretty awesome. I do want to cover it. It's a little bit, there's some of this on ASE, but the people who really know this stuff are fewer and fewer. I'm not really that guy. I know it better than you, so I'm going to show you as much as I know, but this isn't really current testing. Okay. The current testing is going to be more scan tool, like all that stuff. I know all that really well. Some of this stuff, it's just before my time. Okay. So if it was 1980 or 1970 something, all this, what we're about to do right here, would be extremely relevant, but not so much right now. It's still good to know. All right, so check this out. Do you see this shape right here? This is measuring voltage. All right, so when we're measuring voltage, we'll just start with this. The voltage was here, and it was going along, right? So the more right we go, this is time. This is voltage. This is the oscilloscope screen. Cool. So the voltage was fairly high. We turn on the transistor. The heck does that mean? That means if we turn on the transistor, that means we just connected it to ground, okay? Remember, if the transistor's open, there's no ground. When we want to start charging the coil, don't we need to connect it to ground? All right, cool. When we connect it to ground, the voltage will drop. All right, so boom, the voltage drops. The voltage goes down. Right here is where the coil's like, all right, it's pretty charged up. We're good. See the voltage pop up. Right here, we turn the transistor off. What happens when we turn the transistor off? What happens when we take the ground away from the primary ignition? Remember how that coil primary magnetic field collapses and it induces the electricity into the secondary? And what's that cause? The spark, right? Bingo. When I want the spark to occur, what do? I turn off the transistor. Right here, this starts the spark, okay? The height of this line is going to be very critical, right? And then the spark is going to continue for an amount of time, and the shape of this line is very critical. And then, you know what we're going to do? We're going to, the spark is going to be completed, and then to recharge it, we're actually going to, this is it discharging, it's oscillating like it's using its last little voltage. Then we're going to have to turn the transistor back on to charge it. It's going to be charged, turn it off, spark it, burn it, leftover coil energy, turn it back on, charge it, have it be filled up, spark it, burn time. The coil oscillations is like, hey, we're no longer burning, but there's still some energy in the coil, right? So this waveform can tell us a lot. To pull this waveform, though, we have to measure the voltage of the ignition coil primary, okay? So if we probe the ignition coil primary and measure the voltage and we graph it correctly, it'll look like this. But there's another thing we could do. Sometimes we want to see how many amps are going to flow. So if you want to measure amps, right, measuring voltage is one thing, measuring amperage is different. If you want to measure amps, remember how the transistor turned on? The transistor turned on and we start ramping up the amperage. And then when we're pretty content with how many amps have flowed in, or when it's full, I should say, you'll notice the amperage is going to kind of drop off because it's already pretty full. And then when we turn the transistor off, why do you think the amps drop to 0? You switched it off, right? So like if you turn the switch on, amps are going into the lights. And then when you turn the switch off, there's no more amps, right? So this is just this. This is exactly the same, except right here's the voltage level, the electrical pressure, and right here's the amount of electrons that are flowing, the amperage, the current. Okay, both can tell us information. And again, are you going to do this on a regular basis? I would really argue no. But the ASE does ask some of these questions. And I've always been a little soft on it because it's like I read about it, I learned about it, but I would not commonly be hooking up an oscilloscope and measuring these waveforms to do an ignition misfire diagnosis. You know what I'd be doing? Checking for spark, switching the coil, measuring the voltage of the primary, but I don't necessarily normally need to see this whole diagram. So this isn't what I normally do. All right, just in fairness. But I want you to know it because it's on the ASE. And I think the more you know, the more tools you have in your tool belt. But if you're feeling a little overwhelmed already, be like, it's okay if I don't totally understand this. This is kind of advanced. For you, no. If anybody's, if at the end of this semester, first off, electrical engine performance is usually broken into 2 pieces, right? So if at the end of this class, you're like, hey, you know what, I want to do this, let me know. I'll give you all the study guides that nobody even has access to because they're mine. But I would say before you go after A8, I'd probably do engine performance 2. And I'm going to try to get us pretty close to that. But that class is a whole additional semester. And usually engine performance is obtainable at the end of that one. So I don't know. Now I'll go to Bob and be like, hey, let me teach you engine performance 2. And so that way, you guys could be really ready. But I told them the same thing for electrical, right? I did electrical 1, but not electrical 2. So it's like, I want to really nail both of those down, but not that many students continue on to electrical 2 and not that many continue on to advanced engine performance or engine performance 2, So yeah, if you want to go for the SEs, I'll give you every resource I got. But just so you know, some of the reason I cover this stuff is not because you're going to do it every day, but because it may be on the certification test. And, this is a good thing to know because once in a while you got a real problem car that's like, I don't know, I've done all the basic things, it's still messed up. this could give you full illumination of what the actual problem is. It's just, this is 1 out of 100 or maybe less. So we're going to spend a bunch of time on the very rare situation, whereas sometimes I like to put the time in the one that you're going to see a lot, which we already talked about. Cool. All right. So when you go to do this, you really need to use a digital storage oscilloscope, so a DSO. So if I just say oscilloscope, you got me. I may say picoscope. Remember we talked about those? The picoscope is a DSO, but it's one that's Windows based, which is just my go-to, right? So we're going to get some oscilloscopes out today. Cool. So this is all oscilloscope work. The trigger identifies the position of the cylinders. So the trigger basically anchors the waveform on screen. If you don't anchor it, a lot of times stuff's moving all crazy. So we're just going to anchor a trigger, and that's going to be a set time so that we can start to really look at that waveform. Just so you know, it's some oscilloscope stuff. And then the voltage and the time per division settings, that's all going to affect the shape, right? So if your shape was supposed to look like this, but it looks kind of the same, but it's like really condensed, it might be because you have your time per divisions messed up. So you might have to make each of these divisions not 1 millisecond, but make each one of these, let's say, a half a millisecond, and that would stretch it out, right? So some of the settings are going to change this shape. Or if you have this exact shape, but it's really short, that might be because you have the voltage adjusted too high. You might need to adjust your voltage down, okay? So those adjustments change the shape. Cool. And then when we look at like a ramp, you know, that's again changed by the voltage and divisions per second. So like, for example, like if you look at this one, you notice how this is really short? Like we're not even using the whole screen here. How could we make this a little taller if you think of it like that? Right, this thing is going between, you see this number 0, right? What's it going up to? Don't you tell me nothing about it, 6 or 7. I swear, if somebody says, we don't use those letters, those numbers. We don't. If you want to use those, if you want to use those two numbers, you say between 7 and 6. Don't you say it the other way around. No. I've been hearing it for the whole month. I'm losing it. It's how I lost my hair. All right. So if it's somewhere around 7 to 6, okay, we could probably, rather than having our scale go from, see, we're going from 0 to 42. We don't need to see up to 42. How about we make the scale 0 to 12, right? And then this would be a lot taller and you could see it in a lot more detail. Would that be fair? You could go in here and you can adjust your voltage range 0 to 12, not 0 to 46 or 48 or 42 or whatever. Cool? That'd be one way to measure it. I swear you're not listening to that right now, Mason. You had better not be. It's brain rot. Okay, here you go. This one looks nice. See, this one you're seeing really a nice shape, right? This one's going up higher. By the way, this one's actually a little bit higher voltage, but this overall looks better. It's a little condensed though. Like it's I don't know, you could probably see the ramping better if we were to have like not 5 seconds, but if we were to have maybe 0 here, maybe 5 here, maybe 10 here, maybe 15 here, right? And we could drag that with this little arrow. Do you know why we actually have it kind of condensed? There's a reason we have this one condensed. What's it say? We wanted to show all the cylinders. No, we want to see all the cylinders. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8. So no, gosh. All right. If there's 8 cylinders, and let's just say this is a distributor style, one coil fires all 8 cylinders. Okay. So this doesn't work on coil on plug. Okay. But if it's a V8 and it's got one coil, you can actually see what the coil does for every cylinder. So right now we're looking at the coil ramping. We're like, yeah, the coil's ramping up clean for all 8 cylinders. Make sense? If there's a problem, one of these cylinders might look a little weird. And you know, just for simplification's sake, let's say it fires 1, 2, 3, 4, 5, 6, 7, 8. If this one was messed up right here, what cylinder would be your problem? Is that 7? 1, 2, 3, 4, 5. We're skipping this. 7. Oh, you're right. It's 7. Yeah. I thought that one was 8, but you're right. Again, 8's over here. All right. So if we were to have a problem on that, we could tell what cylinder it is, right? That's pretty cool. Now, truth be told, no cylinders fire 1, 2, 3, 4, 5, 6, 7, 8. They're going to fire like 1, 4, 2, 7, 8, you know, something like that, right? So you'd be like 1, 2, 4, 7, right? You could figure out which one it is. So this is a type of test that's really nice to determine what's wrong in the cylinder that has the problem, and you can see it on the ramping, the current ramp for that coil. All right. Now, when we talk about the test points, so you know where we're at, and this one's actually a coil on plug, but we need to go for current ramping. We're gonna have to disconnect this terminal 1 right here, which is the positive wire going to the coil. That's where the power flows. So you'd have to disconnect it, and you'd have to put it in line so it can measure amps. Or we can use an inductive clamp, and that can measure the amps, right? But we have to measure the amount of electrons flowing into the coil on that positive terminal. Cool? But then let's just say we wanted to measure the ignition coil trigger, which would be in voltage. We'd actually use this one, which is IGT. That's the trigger. That's going to more be the waveform. So sometimes we're measuring the current ramp on the positive, and generally we're measuring the trigger on the negative, right? So if we were to look back at these, that would be on the positive as an amp. This would be on the negative as a volt. Okay, makes sense? Which kind of makes sense, because if you're measuring the ground, the only time it has good ground is when the transistor's on, right? So when you turn the transistor on, it gives good ground. When your transistor's off, it doesn't have good ground, right? So there's, you know, a little explanation of that. So we're just looking on the diagram. When you go to take this test, you got to know where to poke your wires. We're going to be poking generally for the positive for amperage, and generally for the negative, but not the negative for the coil on plug, but the actual trigger that the ECM provides. Make sense? Very good. And then this is actually a really cool function. So let's just say you wanted to know both the voltage shape and the amperage ramp. You can check both. You just need at least a 2-channel oscilloscope. You're going to put the green line on amps and measure the amps, and you're going to put the yellow line on volts and measure the volts. And as you can kind of see, this is where the transistor was off. This is on the positive side, which is a little weird. We turn the transistor on, boom. When we turn the transistor on, what happens to the amp flow? Exactly, because we just switched it on. And then it goes up and up and up. And then look, right here, we turn the transistor off. We take the ground away, and boom, the amp flow goes right down, right? So that makes sense. That's exactly what it would do. This is going to show you how the coil's charging, and this is going to show you a little bit more information, which will actually break down, right? But this is an oscilloscope showing both at one time. So if we were to look at this, we looked at this a little bit last time. Here we go. We've got the transistor is off. We turn the transistor on. This is the charge time. It gets pretty full. We open the transistor. We turn the ground off. Boom, this makes a big spike in voltage, and that's measurable with our picoscope, with our oscilloscope. That E line right there, that's going to be really important. That's how many kilovolts the coil makes, right? And then it's going to come, that's the initial spike to get the spark started. This is the voltage required to keep the spark going. This is where the spark burn is complete, and there's some coil oscillations because it's a little bit, there's some energy left over, and then you're looking pretty good, and then boom, we're recharging it again, right? So this waveform tells us a lot, and this is a primary waveform. If you want to use, right, primary is 12 volts and ground, you know, we're chilling on that. If you want to measure secondary, you need to understand what an attenuator is. An attenuator is a device that goes on the oscilloscope, and it makes it so that your voltage that the attenuator measures is going to be knocked down to a lower voltage that your picoscope or your oscilloscope can handle. Okay, so an attenuator makes it safe, right? Attenuator will take 20,000 volts and convert it to 20 volts. Make sense? So that would be like a 1,000 to 1 attenuator. A 20,000 volts to 20 volts is 20 to is a, did I say that right? 200 to 1, 20,000. Yeah. Okay. So we're going to take that voltage, something we can handle it, and then we can actually measure the secondary voltage. Okay. Secondary voltage is not measurable unless we use this attenuator. So that's going to prevent the damage. Cool. So there's a little bit of terminology before you're ready. The firing line is the vertical line measured in kilovolts. That's going to be really important. That's the beginning of the spark. Hold up. Wait a minute. Do you see E? The height of E is the firing line. That's how many volts it took to get the burn started. So what do you think if you had a spark plug gap that was really big? You know, that's a big gap to jump. Don't you need more volts to jump a big gap? So what's that line going to look like? Bingo, right there. So if you were to be like really getting this, you'd be like, hey, I took a waveform measurement and cylinder number 2 had a really tall firing ramp, firing line. You'd be like, whoa, wait a minute. That must be having a lot of electrical resistance. Maybe it's an open spark plug gap, or maybe it's corrosion in the wire or whatever. See how it could lead you in a direction, right? So again, this one is just to start the spark. The higher it is, the more resistance there is. Cool? Whether spark plug gap or whether corrosion in the wire harness or in the secondary wiring, the spark plug wires. And then again, the components in a firing line is you have to overcome. Secondary resistance. Oh, by the way, that includes the air-fuel mixture. Your air-fuel mixture can change the amount of resistance in the cylinder because remember, it's got to jump that gap, which means it has to ionize those existing electrons. Depending on your air-fuel ratio, it'll change, right? But also the amount of compression. So the higher your compression is, the more resistance there is for that spark, right? What if you had low compression? Wouldn't that make low resistance? What would that do to this line? Bingo. Do you remember in the beginning I said the wizards of the old school, they could actually tell if an engine had low compression by measuring the spark primary and primary line? It's like they measured, you just measured the primary circuit of the coil and you're telling me that you know which cylinder's low compression? That's gnarly. Like, that's pretty cool, but that would be why. If the compression was low on that cylinder, this firing line would be lower. Cool. Part of the reason we don't really do that is you guys remember we can use our scan tool a lot of times to do a relative compression test, you know, so we got other ways to do it now that they didn't have. Right, cool. Secondary components, spark plug wires, cap, rotor, you know, anything that could add corrosion would change that. And the spark plug itself. Right, and so what we're about to talk about with secondary, it does vary depending on what type of system it is, right? So if it's an HEI, which is like an electronic distributor type, high intensity ignition, high energy ignition, distributor ignition system or distributor-less ignition system, coil on plug, that could be even wave spark or whatever. These are all a little different. Okay, so you're going to take this as a basic lesson. And if you really are testing a specific vehicle, you may have to reference service information to get the exact waveform it should have. Don't assume that because your waveform doesn't look like this, it's bad. Not every waveform is the same depending on the coil design and the system design. But we'll still discuss it as a baseline, right? So let's say we look at this. We got firing line differences here. If we're saying normal is right here, right about 4 kV, I would say this cylinder looks good. This cylinder looks good. Oh, you know what? Actually, this is 8 kV. That 5 is a different scale, right? So I'm going to say if we were to call it, this is cylinder 1. Yeah. Cylinder 2 looks good. Cylinder 3 looks good. Cylinder 4. Cylinder 5 looks good. Cylinder 6. Cylinder 7, 8. And then maybe this is back to 1, or maybe this is a 4-cylinder, whatever. We can tell what's normal and abnormal. What do you notice about this first one? It's low, but what did low mean? Do you remember? Low means high resistance or low resistance? Less. So maybe this has low compression in that cylinder. Or you know what? It just started, so maybe we didn't get the full scale. I don't think we got a full reading on it, but I'm just saying, if this one was in fact low, that would mean that it has low resistance. Maybe that spark plug is fouled or something, right? But look at, let's say this is 1, this is 2, this is, look at 3 and 5. What do they have? A really high firing line, or a really high spark line. So what do you think would cause really high? Brian, don't answer anymore. You got it. We got other people who didn't get it. Okay, why would it be really high? If really low meant low resistance, what does really high mean? High resistance, but why though? Could it be corrosion in the spark plug wire? Could it be corrosion under the cap and between the rotor and the cap? Yes. Spark plug wire, yes. What if you had a spark plug gap that was too much? Isn't that adding resistance? That would cause that. What if you had a spark plug that you dropped and the gap got closed up? What would that cause? Low, exactly. See how this image right here can tell you a little bit about your cylinder, about what you got, tell you a little bit about what's happening. So if it's high resistance, maybe you have really high compression, maybe you have corrosion, maybe you have a really big spark plug gap. If it was really low, maybe you have low compression, low resistance, or a really small spark plug gap, right? This can tell you a big story right here. And I typically see 1 or 2 of these questions on the ASE. It's not a lot, but there's something. Cool. All right, so high secondary voltage, lean air fuel ratio, increase in cylinder pressure. The spark timing being retarded does make it harder for it to jump. So we talk a little bit about spark timing. We talked a little bit about timing in the beginning. We talked about mechanical engine. If your timing is not advanced enough, it will make this line higher, but which cylinders would be affected? If your distributor is a little bit retarded, which means behind schedule, which cylinder would that affect? All of them, bingo. All of them would be affected, right? So this one we could be like, yeah, this could be the case, but it's only affecting 1 cylinder, so that one's out. An increase in the air gap, yeah, that could be the case, right? All these would cause the high secondary voltage, high firing line. All right, pretty cool. And then again, even the type of ignition system and engine operation, mechanical, we can't give a specific number because again, it depends on the system, right? But if this one, for example, you were to look, which one of these do you think looks abnormal? I would say so. So it's either maybe 2, 5, 6, and 7 are too high, but maybe number 4 is too low. How would we know? How would we know? How would we know? You're going to have to look up the specs for that specific ignition system, right? So if it says, oh yeah, normal is 10 kV and you've got 10 kV on only one and you've got 15 on the rest of them, you're like, I mean, that'd be kind of weird, right? That'd be abnormal. But you got to follow the specs. Now, probably more realistically, 12 to 15 is normal, 10 is too low. Something's up with this one. Maybe it's got low compression or something. Speaking of low, interesting. Low secondary voltage. Okay. So because the higher resistance in the cylinder, the more voltage required, the opposite would be true as well. The less voltage that was required, the less resistance in the cylinder. Make sense? So we know we're looking for super rich air fuel ratio or low compression, or maybe the spark plug gap is closed up because of this number 2 right here. Okay, makes sense? In fact, we're going to call it 2, but in reality, this firing order is 1, 4, 2, 5, 3, 6. So this cylinder 1, what's this one? 4. So we're really looking at cylinder 4. Go to cylinder 4 and inspect it. Make sense? 2, 5, 3, 6, 8, I believe. Right. Oh, this is a 6. So yeah, we'd be back to 1 right there. Okay. And again, low secondary voltage, fuel or oil fouled spark plug. Why do you think that makes sense? Close. It's low secondary voltage, which means it's easier. The foul doesn't block it. I thought it did too. It's almost like, yeah, it doesn't have a clean ground, but actually the fouling gives it a path to ground that's a shortcut. It's easy. It's the path of least resistance. If it's got an easy path through the carbon fouling on the spark plug, the voltage won't be as high because it's easier. Make sense? So fouling would cause a low firing line. Okay, it could be cracked on the insulator, which would mean it would probably arc past the insulator right to the casing, right to the head, or right to the spark plug. A small spark plug gap, rich air fuel ratio, spark going to ground external of the cylinder instead of overcoming cylinder pressures. And finally, low cylinder compression. But let's discuss that one. What do you think we mean here? Spark going to ground external of the cylinder. What do you think that means? It's arcing to ground, but where? So it didn't even make it to the cylinder. It didn't even try to jump the spark plug. It's just like, oh, I got ground right here in the valve cover. Zap, 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 zap. That would be low. That would be one of your cylinders would be low. Make sense? Okay. And then if we have high secondary voltage, again, that could be, lean air fuel ratio, worn spark plug gap, high resistance in the wire or the boot or the plug or, whatever. Maybe it's a coil on plug and it has the little spring contactor and it's rusted due to water intrusion, right? So like it was saying, too wide, high resistance, lean air fuel, high resistance in the spark plug wire, worn or corroded distributor cap or rotor. That wouldn't be the case if it was coil on plug, but if it's a distributor, yes. Carbon buildup on top of the piston or in the roof of the combustion chamber. What? Why would that be the case? Why would carbon build up on top of a piston cause a higher kV firing line? It's a good idea. Think of how compression occurs, right? We pull down, we pull the air in, and then we compress it up into the head. If there's carbon on top of the piston, doesn't it make the combustion chamber smaller? So isn't it more compression? If it's more compression, it's going to be a higher firing line. So you'd be like, whoa, that cylinder has a high firing line. It could have excessive compression. How's that happen? It's maybe because of carbon. How could you know if it's carbon or not, though? I'll give you a clue. It's got nothing to do with an oscilloscope. I would look down in there, but how would you look down in there? I'd use one of the oscilloscope, the borescope cameras, or like an endoscopic camera, send down, be like, let's say it was cylinder 2. I'd look at 1, it looks clean. 2 looks carboned up. 3 looks clean. Be like, yeah, there you go. I can see the carbon in there. I wouldn't have initially checked that though. The firing line would have led me to check that. You could also do that with a compression test. Cylinder 2 compression would actually measure higher with the compression test gauge. Cool. All right, and then of course, retarded timing and a high firing line, which will have a shorter spark duration on any ignition system. So if we have a high firing line, that kind of uses up the energy of the coil faster. It might not be able to maintain that burn time, that spark, long enough to be really consistent. So that can cause a misfire. Okay. Like we were saying, lean air fuel ratio, low fuel pressure or volume. Lean air fuel ratio, that's its own big lesson, but just know lean. Too much air, not enough fuel. Worn spark plugs is the leading cause. So if your spark plugs are worn, that gap is bigger, the resistance is up, the firing line will be higher, right? And then anytime it's like a, excessive resistance in the secondary, And if it's a distributor, we got to be looking at the coil, or we got to be looking at the cap and the rotor and the wires and any sort of corrosion in there. That's kind of why we do the tune-up, right? We talk about making all these measurements. We know that we have failures in those systems. If we just do the tune-up at 24,000 miles, we're probably going to avoid a lot of this diagnosis, right? So now if we look at how this goes, in this system, the firing line should be between 5 and 22 kV. The higher the resistance, the higher the kV, right? So again, we're really drilling down on that firing line a lot. It depends on the system. If it's distributorless ignition system, 5 to 22 kV, it depends on the system. And then just a summary, like we kind of talked about, compare one to the other. Let's say we have, let's pick corroded high voltage coil on plug spring. If it's corroded, doesn't that sound like high resistance? Then yes, that's a high firing line. What if we had a coil on plug boot that was arcing to the cylinder head? Does an arc, isn't that a short? Isn't that low resistance? Right, then it would be a low firing line, right? So consider referencing this if you get yourself confused. What's a high firing line and what's a low firing line? Make sense? Okay, then the burn time is shown right here. This is where the spark starts. That's the firing line. That's the kV like we talked about. But then how long it lasts is going to depend on a few other things, right? The air in the fuel mixture is ionized. The resistance decreases. That's when the spark is going to continue to arc, right? So the spark to you is just a boom and it's over. But in reality, the spark starts and it keeps on arcing until it doesn't need anymore and all the combustion should be complete, right? So the burn time is right here. This is the actual burn time. All right, so sometimes we'll call it spark duration too. We need a certain amount of burn time to completely consume all that air and fuel. We need to burn it all up. If we have a short burn time and we leave air and fuel in the cylinder, why is that bad? You want to get bad gas mileage because that's how you do it. You leave the gas in the cylinder and then you pump it out the exhaust. How do you think your emissions are? Bad. How do you think your catalytic converter feels? Dead. So right. So like if we don't have the coil that can provide the burn time appropriately, we're going to have bad emissions. If we have a really high firing line, remember that takes a lot of energy because your spark plug gap is too wide. We might not keep this burn time long enough. We might leave fuel and air in the cylinder. Bad emissions, bad fuel economy, bad catalytic converter, you're failing smog, right? And it all might just be because your spark plug gap is too wide and you're like, what? That was it? I just needed spark plugs? Yeah, that happens. That will change your emissions levels on your tailpipe test for your smog. Absolutely. Okay, cool. So again, here's your burn time, and it can have a little bit of different shape. Now, if you look right here, this is a little bit exaggerated. But you notice how it kind of came back up? It came back up. That's a lot of times maybe there's a little bit of an uptick would be normal, but this is really ramped up. That could be like a lean condition in there, right? So if you really wanted to get super geeked out, you can look at the shape of all these, especially this first shape right here. That can tell you a lot about what's going on in the cylinder. That's not really my go-to for diagnosis, to be honest with you, but it's a little more old school and it's still relevant today. Myself personally, like we got fuel trim and scan tool stuff we could do, but just so you know, that drastic of an uptick, maybe looking at like a lean condition. Cool. What about our burn time? So if you look at this one, you see how this one has a pretty nice burn time and it's got a bit of an uptick. A little bit of an uptick could be normal, right? That's healthy. But compare this burn time with where's this burn time at? We had a really high kV and then it was like, nope, the burn's over. And now this is coil oscillation, the coil spent. This burn time was too short. Well, why? I don't know. It seems like the spark line was so high, maybe it used up a lot of the coil's energy just trying to make that initial jump. Maybe we've got a wide spark plug gap. Maybe we've got excessive resistance in the wiring or the coil boot or something, right? So the higher the kV is, you'll notice typically the burn time is much shorter. So we got some issues on there. A little hard to say what it is. There's a few possibilities. Okay. Let's go with the potentials. If we had a short burn time, maybe distributor cap to rotor, maybe spark plug. And the other thing is sometimes we'll get them where there is no spark at all. So I'll show you no spark one just a little bit. But if we look at this one, there's our kV line. Here's our burn time. This we call the nose right here, okay? This up right here is the nose. The nose is a good way to evaluate some of the things that are happening in the cylinder. Right, and then these are the oscillations. What the oscillations are, that's basically the coil's voltage kind of going up and down as it's been discharged and it's kind of stabilizing. It's spent right here. By the time you see the oscillations, it's got like a little bit of energy. If it was dead flat, it'd be empty, but that means the burn time is over. We're done. Right, and it should have a little bit of an uptick like it does. If it's got some energy left in the coil, it should. Okay, so there's a bit of leftover energy there. If you look at that nose, if you had excessive spark gap, turn up, or the actual spark line itself. So this spark line was kind of ramping downward. If that spark line were to be bent up, you could be looking at an excessive spark gap. An excessive spark plug gap, the firing line would be high, and then this would be kind of going upward, maybe spark plug gap. If there's spark outside the combustion chamber, it will be straight, but totally straight because it's not varying in cylinder pressure or resistance. It's just arc right to ground. Let's say we were to have, for example, low compression. That would be straight. But if we were to have carbon buildup and high compression, that would be bent up. Or if we were to have rich air fuel ratio, that would be bent down. So if you were to have this one's going down, but like it's fairly straight. If it were to go down a lot, that would be maybe rich air fuel ratio, right? So the spark lines can tell you a whole lot of stuff. This is pretty normal. You know, on that last one, it looked really flat, but in reality, it usually looks a little bit like this. It's relatively horizontal. It's not really up. It's not really down. There's a slight increase of the voltage at the end. That's mainly because compression is coming up right there, which increases the resistance. So it increases the voltage. That's normal. Pretty healthy. That also indicates that the coil still has enough reserve energy to burn it. So if your compression's coming up and this thing falls off right here, that might be like, hey, your coil is not able to really overcome that compression. So there's a lot of information on this piece. This one, for example, is lean. So you had the firing line and it came down and then it was really high spark line and it's falling off. And you'll notice it didn't have any uptick right there. If you read it like this and that were to tell you it was lean enough will cause a misfire. So if you have a misfire and you're thinking it's spark, but you graph it and it looks like this, it's like, no, you know what? That one's lean. Maybe it's an injector that's clogged, or back in the day, it'd be a carburetor that's air fuel ratio needs to be adjusted. That would be the shape. What if we had a spark plug that was grounded? Look at your firing line. If you were to have, there's no turbulence at all. So you basically have your coil fires, the firing line's low, your burn line is kind of falling off, and there's really no turbulence. It's very smooth. Normally, we'd see like some turbulence, which is like the compression building in the cylinder. This one's so smooth, it's too smooth. I think that this one could actually be arcing. This one could be arcing to ground or you know something. But at least we know that the spark occurred because this is showing the spark. It just doesn't seem like the spark's occurring in the cylinder. It seems like it's occurring on the valve cover or something. Right? Now, if you were to look at this, this would also be a short to ground. But do you notice the difference? This one is a short to ground, but it arced up at the end. This one is short to ground. See, it's going downward, but there was no uptick. This doesn't even look like any spark occurred. You notice there's no real oscillations. It was more like, it wasted its energy, but there's no turbulence when there's an actual arc being carried at the spark plug or at the shorted at the valve cover or something, right? That one's at least showing us a little something, not turbulent in the cylinder. This is more like in the cylinder. These are in the cylinder. That one seems like it's out of the cylinder. That one seems like it didn't even spark. It just discharged, right? That'd be like a dead short to ground. Like you have the spark plug wire literally touching the exhaust manifold. It's grounded. It didn't even make an arc at all. Okay. And if we were to look at these, you could see multiples. So if we look at cylinders 1, 4, 2, 5, 3, and 6, you'd be like, yeah, I don't know, 3, 4, 5, 6, pretty high firing voltages. Interesting. If I were to look, I would say 1 looks like a little bit low. I think 1 is this one, 4, 2, right? You can tell there's something going on with these two are a little low, but then if you look at 6, 6 is different. 6 has a good initial spark line, but then 6, if you look at the burn, is high. It's taking, it didn't take more energy to start the burn, but it took more energy to maintain the burn. That's not usually going to be like a spark plug gap, right? If it's a spark plug gap, 6 would be high on the firing line. The firing line's normal, but the continued burn is kind of high. I think maybe it could be lean. I think it's probably like lean air fuel ratio because it's harder to keep that burn going when the fuel's lean, fuel trim's lean, right? And then let's say that you, right, this one had a lean condition. What do you think? What kind of injector problem would cause lean? Not enough fuel and too much air. What would be an injector failure that would cause lean? What do you guys think? What if its injector's kind of clogged and dirty? Will it spray enough fuel? It should spray a lot, but instead it dribbles a little bit. Wouldn't that make it lean? All right, so let's say we said, hey, you know what? I think this is a lean misfire. Let's clean the injectors. You clean the injectors, you put it in, and now it goes like this. Does it look fixed? Heck yeah, this was bad. You clean the injectors, now it looks like this. You can actually tell your injectors are working based on your spark line on your oscilloscope. It's pretty cool. All right, and then like we were saying, the lean air fuel ratio, a lot of times that's going to have a high KV for the burn time. It's going to require additional secondary voltage, right? And that's why this would be higher. So that's kind of what that was saying here. This was lean. We fixed the injector. Now it's normal. It's just summarizing what lean would be looking like, right? And then there's, depending on a lot of different specs. For example, if your spark, this might be a little hard to see in the back, but if your spark plug duration is below 0.8 milliseconds, that could be a wide gap. Or in a little bit, we'll cover the snap throttle. The snap throttle will change our line. It'll tell us a lot of stuff. For example, if your snap throttle burn time is below 0.8 milliseconds, maybe it's a lean air fuel mixture or excessive in-cylinder turbulence. If your snap throttle burn time is long, above 2.4, that could be like a fouled spark plug or a narrow plug gap. If you have low resistance, the burn is going to continue longer because the spark plug, because the coil is not having to put out as much voltage to jump a big gap, right? It's can send more for longer. Cool. So when we do coil on plug, it's similar, but there's a bit of a difference. So when we were back on this, can you see all your cylinders, 6 cylinders? With measuring 1 coil, because 1 coil fires all 6, am I right, on a distributor? What about coil on plug? 1 spark plug is going to fire, 1 coil is going to fire 1 cylinder. So if you want to check cylinder 1, you got to probe cylinder 1 ignition coil. Make sense? So this right here is only cylinder 1. When you go to do this, there's different ways, but like on a distributor type, you had the spark plug wire, and you could use the spark plug wire with an inductive clamp. But with a coil on plug, remember how that looks, right? The coil sits down and the boot goes down in the cylinder. How the heck are you going to measure that? You can't clamp around it. You need an inductive clamp. Sometimes they look like fly swatters or something. I'll show you what that looks like. You could measure one at a time, right? So this would be your cylinder 1. If you want to look at cylinder 2, you gotta do the inductive on cylinder 2. There is a way where you could do all of them, but it's a little harder to do because you're actually measuring 8 coils or 6 coils or whatever, however many cylinders there are, and you need to have them measured separately. So you can't use one channel oscilloscope to measure all 8 cylinders. You need 8 channels measuring 8 coils all at the same time on one screen. It's a little different, right? So, and this one's just like, if we had compression issues, we could diagnose. I think we're probably good on that. This is actually good compression. These ones would be maybe low, maybe that one, right? I think we're good there. When we do the snap throttle test, we're going to do the same exact thing, except we're actually going to jump in and snap the throttle, bam, and then pop right back off the throttle. That's going to actually change this line a little bit. That's going to show us a little bit more. If we had poor spark conductivity, it might be like show a little bit high secondary. Then you might see the shape is a little bit different right here. It's kind of trying to maintain really high KV because there's resistance in the cylinder. The snap throttle test can unmask issues that are hard to see. Okay, that's mainly why we're going to do it, especially if it's intermittent, right? So let's say you do the regular test at idle, it's got a high KV line. You do the snap test, the high kilovolt firing line with no spark line, or it's got a whole lot of movement. That sounds like that could be a lean condition. If it has little to no change, that could be, that might also be potentially a lean condition. Generally, if you do the snap test and the spark line doesn't indicate an increase in voltage and slope, it could point to poor secondary circuit insulation or engine mechanical problems. So the snap test would be, a good test to do. So like, here's all the cylinders. On this one, it looks like we had excessive cylinder secondary resistance right here on this cylinder. See, these ones look decent, and then this one really fell apart. So that would just point out, hey, we got an issue with cylinder 3. Maybe we got excessive resistance in there, or it could be excessively lean. And then as far as primary and secondary go, if you look, your primary is going to be the lower voltage and your secondary is going to be the high. But what would you say the difference is between these two? They look kind of the same? Well, that's my lesson to you. Whatever happens on the primary will happen on the secondary. So typically, we're just going to go ahead and do the primary waveform because we can access the primary with back probes fairly easily. If you did need to do a secondary, you can, but your secondary is going to match your primary. It's just going to be at a higher voltage. So if you insist on doing a secondary, cool. But a lot of times you can really get it from the primary. If it's a distributor and you only really want to see one cylinder on the secondary, you'd need to do secondary. But because we're dealing mostly with coil on plug, every single cylinder has its own primary. So we're really just going to measure the primary. That's our main goal. If you did need to use the secondary, this is the type of stuff you'd use. You'd have to get a clamp, and this would be inductive, and you could hook it up and hook it up to the oscilloscope. It looks like this. This will go around a spark plug wire. That'll connect to the oscilloscope. But if it's a coil on plug, you can't go around a spark plug wire. There is no wire. So do you see this thing? I call this the fly swatter. It's a coil on plug paddle. You can actually set it on top of the coil, and it'll pick up through induction the primary voltage. And again, the primary voltage is a replicated image of the secondary voltage. You can pretty much see everything you want to see with just this. But this will go and be connected to the oscilloscope, and you can pretty much see what you got. You can see the waveform, determine that. They also have a little bit of other designs. So like, for example, this one will you'll wave near the top of the coil, And right here, you can see that you'll make the connection of the wire to the oscilloscope. You guys can see what brand this one is. That's a Pico. So that's a good way to check it. Some of these are flexible. But that's all secondary. If you want to do primary, it's much more simple. We just got these leads. And you're just literally going to back probe. And you guys should remember, we're just going to back probe. If you're doing voltage on the primary, we're going to measure the switching ground. If you want to measure amperage, we're going to interrupt the positive, go into the coil, break it open, and then continue it. Because remember, the amperage needs to go through the tool. Or in this case, we'd probably use an inductive for amperage if it's going to be a pico. Okay. I think you're kind of ready to do some of those tests. I think it's a little bit intense. A little intense, but kind of normal.